Shriram, your mic is
Mike, Sriram, Mike.
Okay, fine. Yeah, I am audible or not?
Yeah, you are.
Okay, then thank you. A warm good afternoon to all the veterans, teachers, participants, and the coordinators present here. Although this is a valedictory function, as Varnatan said, this is also going to be the concluding session of UL Space Club World Space Week Celebration 2021. And I'm not going to say a word about our activities in this pitch of time. It will be given to you or informed to you by others soon after the official inception of the function. So I'd like to merely comprehend the idea behind the WSW celebration, such as when it started, what's its purpose, why it is so significant, and how it goes this year. By Resolution 54/68 of 6 December 1999, the General Assembly of UN proclaimed the World Space Week to celebrate the contributions of space science and technology to the betterment of the human condition. The World Space Week is the largest annual space week, the space event in the world. The week helps build up the workforce of tomorrow by then demonstrates visible public support for the space program, educates the public about space activities, and also fosters the international cooperation in space outreach and education. But why October 4th and October 10th? Because it was on 4th October 1957, the launch into outer space of the first human-made satellite, Sputnik 1, which weighs like a baseball, opened the way to the space exploration. A decade later, on 10th October 1967, the Treaty on Principles Governing the Activities of States in the Exploration and Uses of Outer Space, including the moon and other celestial bodies, entered into the force. The first ever theme was launching the space millennium, obviously in 2000. And this year's 2021 theme of the World Space Week is Women in Space. With this theme, we will bring more awareness to the issue of gender diversity in the space sector and identify the obstacles that women are facing when entering space-related careers and contribute to the discussions on how we can overcome these challenges. According to some reports, 20 to 22% of the entire space industry workforce is now covered by women. We are mindful of women from different backgrounds and from different regions facing different issues, and we are aiming to shed light on the difference. So that's all about the World Space Week in just 2 to 3 minutes. And my watch is approaching 3:01 p.m. And I would like to invite our UL Space Club member Ashri without any other delays to commence the program and for delivering her welcome speech. Over to you, Ashri.
Okay, thank you, Shri. Am I audible?
Yes, you are.
Yeah, you are audible.
A warm good afternoon to all. Today we are gathered here for the valedictory function of UL Space Club World Space Week Celebrations 2021. We celebrated this Space Week by conducting 15 webinar sessions at 46 schools and a skywatch session with Sky Safari, a community for amateur sky watchers under US Space Club all over Kerala. Without any further delays, we can go to the official welcome speech. First, I welcome our chief guest, Shri S. Somnath sir, distinguished scientist and director of Vikram Sarabhai Space Center, ISRO. He joined VSSC in 1985 and worked as a team leader, project manager, deputy project director, etc. for ISRO's major missions of PSLV C4, GSLV Mark III, etc. And also he is inaugurating our valedictory function today. Welcome, sir. Next, I welcome the speaker of today's exclusive webinar session, Dr. G Sreejalekshmi ma'am, Associate Professor at Indian Institute of Space Science and Technology, Thiruvananthapuram. She joined IIST as the founding faculty in the Department of Applied Sciences in 2007. Currently, her team is developing a biology payload for the first developmental flight of Indian human space program. She is the speaker of today's exclusive webinar session on the topic Life into Space and Introduction to Space Biology. Welcome, ma'am. And I welcome our Chief Mentor, Shri E.K. Kuti sir, Shajal sir, Jayaraman sir, Abhinand, Bharat, and all other members of UL Space Club, and also welcome all participants who are present here. And I invite Abhinand PS for giving an overview. Thank you.
Thank you, Shri. Thank you for inviting me. Unfortunately, I can't switch on the camera because the network here is very poor, and twice I have met with some problems when switch on the camera. I'm sorry for that. Firstly, I apologize for that. A warm good afternoon to one and all. Today we are blessed with the presence of our Honorable Chief Guest, Somnath sir. I'm here to, my duty is to review the program, that's happened in the last 1 week. As you all know, today is the concluding session of our World Space Week celebration. We had conducted a diverse number of programs, and we had got a very great participation from many of the enthusiast students. There is about 200 plus schools are registered for our programs, and we had conducted many programs, including the webinar at the school program, Skywatch, and rather some other programs also was there as a part of our Space Week celebration. One program which I was like to mention is our webinar at the school program. Webinar at the school program was such a success. We had done almost 15 plus webinars, and we clubbed these schools to 4 schools, and we made a presentation for every group. And one member from our space club had done presentation for one group, and we had almost 12 members from the space club had done presentations and a questionnaire session. That was very interesting, and everyone got a chance to interact with students, and we had got many number of questions to clarify with experts, and we expect many more sessions with the UL Space Clubs to clarify these questions itself, because there is very interesting questions from the students, unexpected questions and all, and that was a very fascinating experience for everyone. They participated in this program. We had conducted a Skywatch session. That's called Sky Watch with the Sky Safari. We have a initiation called Sky Safari. It's for looking in the sky and studying about astronomy and astrophysics. And that program was very, very interesting. Indeed, we know that dark sky is one of the features that has been essentially unchanged throughout all the human history, that's shared by all cultures throughout. And though it is being interpreted many different ways by different cultures, so we had conducted this Sky Watch program in a way which is like a fusion of sky, stars, astronomy, astrophysics, even history and literature. Our renowned astro columnist Surendra Punnacheri had conducted these programs. And one thing which surprised me is that every student, almost everyone, they had came for the program, sit at the last of the program, and the program ended at the mid of almost 10 o'clock, and everyone stayed for the program. That was such an exciting program. And along with these programs, UL Space Club is also conducting many other initiatives. Our initiatives from sky, stars, space, and many other things. One of our initiatives is called Cosmos. It is to discuss about the space and these things. Other one is called Orion. It's our outreach program. Now, in the last, we had take up an initiative called Wings of Fire. It's an initiative to discuss, it's a platform to discuss for interdisciplinary subjects. We know in the Space Club, we are mainly discussing about the space and all things, but we have an interdisciplinary platform to discuss about these subjects, and the discussion is very interesting. Cosmos is also having a discussion. Once I seen almost 500 messages in Cosmos every day. So it's very interesting platforms. And personally, I also benefited a lot from the Space Club activities. Every student in the Space Club have it's like a window for every curious student. The Space Club is acting like a window to every curious students. And from my personal experience, I know I had got opportunity to interact with many great personalities like U.R. Rao sir, Dr. B.N. Suresh sir, and even our Honorable Chief Guest, Somnath sir. Twice I got opportunity to interact with Somnath sir. That was a nice experience. And once I got opportunity to witness the launch of PSLV C42, that was a spectacular event. I never expected such a spectacular event there, and that was a great opportunity. I'm very sure that every one of these students will get such opportunities in the future, and they will all benefited from these programs, and we will get very good collaborations from the side of ISRO and all other premier institutes. And I'm very grateful for these institutes, and I thank all these institutes for, in behalf of me and UL Space Club, for collaborating with us. And once more, I thank our chief guest, Somnath sir, for coming today. Sir, we are all excited to hear from you. I'm not spoiling this time by just reviewing all these things. Sir, thank you.
Kutisa, your mic is muted, sir.
Mr. Jairam?
Sekakamo.
Oh, yes. Welcome.
Ah.
Welcome.
Very good afternoon to everyone. Respected Director VSSC, Somnath sir, Pappan sir, Bud sir, Jaraman sir, and Sreejalekshmi madam, Kutti sir, and CBS Dutt sir also, and all other veterans and senior scientists and my dear children who are participating in this program. Once again, a very good afternoon to you all. Abhinand has nicely put forward the perspective of what he experienced with the ULCCS, as also a brief overview of what transacted here under the aegis of ULCCS for this World Space Week 2021. This one. I am going to personally share some experience from an associate's point of view, or you can they call me a mentor, and I'm very happy to be in that role. So my association started somewhere during, I believe, in the late part of 2018 when I came to Calicut and settled down here. My dear Kutti sir gave me an invitation to one of those annual space clubs, space events, camps that was being organized under the aegis of Uralanga Labor Contracting Society at that Iringal Craft Village. I went there as an invitee and participated for 2 days program, and there was no looking back. I became an associate, and I'm extremely pleased that over the last 2.5 to 3 years, I could walk along with these gifted children, a bunch of bubbly and effervescent children, and equally committed teachers and committed parents, all working towards finding the best of the students to be associated and oriented towards activities in space. And in fact, we are doing a silent revolution in this part of Kerala, and of course, later part of the year, many associates and many veterans from ISRO joined. And the turning point was really the pandemic, when we were all going towards the second space camp somewhere in Calicut University. It was the time when the pandemic struck, and then we were all, we just broke down, and then we were just stuck in the path. And it was a bright idea by the students then that we should organize seminars or webinars rather. And we started on a small scale. We started originally by going by the space club. We started on space activities to start with, but subsequently the wisdom set in that no, we should not limit.
Any problem, Jairam?
Yes, sir. I think it's a network issue with Jairam, sir.
Looks like he has got stuck. This is the problem. This of
Yeah,
this.
I think I have a problem. I'm joining.
Okay.
Yeah. I come to the mobile mode. Standby. We are ISRO. Backup mode.
Good.
Just switch off one of the mic. Otherwise,
Yeah, I will. Yeah. So we started off.
You switch off one.
One moment. I got the mobile.
You choose.
Yes. Apart from the we started a stellar chronicle. Totally under the aegis of this club, the initiative of the children again, students alone. I happen to be the editor-in-chief. Because the real editors are the kids. So basically, to give a venue for them to express their creative skills in the written format, and that has been going well. And the edition 1 was published during this year at the beginning, and edition 2.0 is now ready. And I'm very happy to state that today we would request Somnath sir to officially release that this one. So there are plenty of initiatives, and the kids are all charged up. And for me, it has been a personal means a fortune to be associated and to be able to give back little to the society, whatever knowledge I assimilated in ISRO. ISRO is a great organization, and I'm very proud to be associated with this activity as a retired person from space as well. So today, I wish everybody happy Space Week Day celebrations, and I don't have anything more to add. I wish all the best for all our students, and once again, greetings to all the ISRO veterans who are joining us today. Thank you.
Thanks, Jairam. It is now the turn of inviting.
So, sir, one more thing I just forgot to tell that is worth mentioning. Here, the whatever activities we are carrying out here is truly voluntary. It is absolutely one single rupee does not get exchanged, and it is purely voluntary. Everybody comes in with their own resources, and ULCCS has been a benevolent facilitator, really. So that is a one fundamental and fantastic spirit of what we are doing here at. This is a unique model. If I don't mention it, I will be failing in my duty. Thank you once again.
Thank you, Jairam, for clarifying further. Thank you. I'm coming to the important event of this today's celebration, concluding celebration, inviting our chief guest, Shri Somnath, for the program. So a very warm welcome, a very good afternoon to each one of you, Shri Somnath, Dr. G Sreejalekshmi, my dear students in the UL Space Club, my friends in ISRO, other veterans, and invitees. Today, we are celebrating the World Space Week 2021 with the support and help of IIST. IIST last year hosted the entire program from their own, and this year, YVN Krishnamurthy told me, you go ahead, whatever support you want, we will give you. And Dr. Sreejalekshmi, we got it in that process, and she has been exciting us on a topic which some of our students are very highly interested in. A special day is today because we have been longing to have Somnath sir with us for very, very long time. It's a long wait for us. So it is coming to a fruition today, and we are having Somnath sir here. Of course, we would wish when the pandemic ceases, when we have time to meet each other face to face, at that time also we will be able to have a blessing occasion to have you, sir, with us. So we welcome you very, very warmly after a long wait. A lot to speak. My job is to introduce Somnath sir. There is a lot to speak about our chief guest, Shri Somnath. We, your Space Club, benefited a great deal from you, sir. Lot of encouragement, support, help we received. You treated our students whenever they visited VSSC so warmly and so fondly. In fact, the students came back and told me that we got a sessions from Somnath sir. Not only that, we had got a lunch hosted by Director VSSC, and there was something very, very touchy for them. So, sir, you have treated our students so well, differently, especially when they went to VSSC. And I got benefited in the Space Club with your nomination of excellent faculties from VSSC. Our students will never forget them. Excellently, they treated the sessions and the students, and that was a strength for our webinar program. And before that, when we were having our space camps in university, NIT, etc., we got very, very veterans, including Dr. Unnikrishan, who was a space flight person at that time. He came and spent a lot of time with us in the university. So it is so nice, a very happy thing. And not only that, I have a personal connection also. We know each other for long. I left ISRO after 20 years of Somnath sir joining there, and we knew each other. And I had also a special occasion to invite to receive him at my home, along with Dr. Radhakrishnan, when Radhakrishnan was director of VSSC. So that is also I remember so fondly. Sir, let me introduce formally. Shri Somnath is director VSSC, also director IIST now. He was director LPSC too. At that time also I received a lot of help. Held several highly esteemed roles and responsibilities, including Associate Director VSSC, Project Director GSLV Mark III, and all that. Shri Somnath joined VSSC in 1985. I left exactly 20 years after that, when I noticed a rising star in Somnath. When he joined, PSLV was in prime. He conceived, executed first-time launches of mini satellites using PSLV. That was a milestone for ISRO. He's an expert in system engineering. PSLV, GSLV greatly benefited. Significant achievements of Shri Somnath as director of VSSC are very many. I would highlight here the crew escape system, GSLV Mark III and Chandrayaan 2 mission. Now he is spearheading Gaganyaan's crew module, human rating of GSLV, etc. Shri Somnath holds a BTech in mechanical engineering from TKM College of Engineering, Kollam. Did his master's in aerospace from Indian Institute of Science. He's a fellow of Indian National Academy of Engineering, Aeronautical Society of India, member International Academy of Astronautics, and a person widely traveled as delegate and representative of India in UN Corpus. UN Corpus is a very, very important wing of the United Nations Committee on Peaceful Uses of Outer Space. He represents India, ISRO in that, it's in Vienna. And there has been a lot of contribution from him to International Astronomical Federation, IAF, International Program Committee, International Astronomical Congress, IAC. In different countries, they have activity. He's a vice president of IAF, member technical committee for space transportation and project management committees. So these are only a fraction of the activities and achievements of Shri Somnath. Sir, I invite you, with the permission of all my friends and students here, to present your talk.
Thank you, Kuti sir. Hope I am audible.
You are, sir.
Okay, thank you for that introduction. Anyway, I have a very short time, 30 minutes you have given me for a talk, and also for inauguration of this concluding session. I am really at loss of words, especially when I am seeing many veterans of yesteryears of ISRO also being there in the panel, listening to me. I believe they are as much as students as they are connected here. So keeping their energies and enthusiasm to learn and hear new things along with the young lots who are there. I also want to congratulate all those volunteering personnel who have teachers, mentors who have come forward to work with the students, to keep their spirits very high, to take them to a journey that their life will take them, but with great enthusiasm and wonder of science and technology. So I also know if I speak to them about space, I'm pretty sure that they know much more than that I'm going to speak today in terms of material and in terms of specific knowledge. I'm very sure about that. So I can't venture on talking about some facts and figures but that I will fail in my duty in really communicating that aspect. So what I thought is that I should speak about, ideas and visions and your preparedness for the future. So that's more important. But it is always associated with some data and facts, so that I can communicate with them what they need to look at life when they choose paths of whether it is space or science and technology or research, whatever. So let me go through a small PowerPoint presentation. The PowerPoint presentation is not important for what I am speaking. It is because I need to put a background when I speak there. So you don't worry about what is there shown in the slides. And that will be passing pretty fast. So let me try to uplink that presentation. I hope it will come.
Presented.
Can you see the screen?
Yes, sir. Yes, sir.
Yes, sir.
Okay, very good. So what I thought about talking today is about technology disruption, space technology, and the excitement and the opportunities. So that's there for young people. So if before I talk, every time I'm finding this particular aspect very interesting and enthusing to everybody with regard to what we are, where we are, and what we are supposed to do in a long time. See, as human beings, we have a special characteristic. See, if you look at every living creature on earth, they simply follow the rules of the nature and live very peacefully. But human beings are the one who don't follow the rules of the natural laws of the universe. They always try and find a way by which to get options beyond what they are, beyond other living organisms can do. One of their important capabilities to explore, realizing what they are. They are nobody. See, look at human beings on Earth. They are just a speck of dust in the scheme of things, the universe. And those human beings who are sitting there in that small Earth, which is nothing compared to the size of the whole of the universe, strive to go, travel and explore new forms of life and new civilizations. And this is what we are destined to be. The simple thought about it itself, makes everybody so excited. And we are at the beginning of those capabilities. That's also something that we need to realize. We have not evolved to such an extent by which we can even travel beyond some of the solar system or planetary system of sun. Even the capability to go to beyond the solar system has never been accomplished yet. Still, we wonder about it, we think about it. I think that is good enough today. I believe in the generations to happen, we will really overcome those obstacles and find new ways. I also want to talk about it. I hope the slides changed. Can you confirm?
Yeah,
Yes, sir. Yes, sir. Yes.
getting changed.
Okay, good. So I know many of you know Arthur C. Clarke when he proposed some of these 3 laws of prediction in his book Profile of the Future, which is also very interesting to me. Before these talks, which is very important. When I make any prediction on the possibilities in the future, we must be remembering that a person like me, when he makes a prediction and also say something is impossible, then possibly it is very wrong. And that also tells you the only way of discovering the limits of the possible is to venture a little past beyond them into the impossible. And it also happens that you really look back a little bit, you will realize that a sufficiently advanced technology is indistinguishable from magic. So even the mobile phone is a magic, maybe few hundreds of years back. Today, it looks so natural to us. So when you look at possibilities in the future, please don't be taken away by the fact that it doesn't look so much possible with respect to the knowledge and the skill that we have today. So this 3 laws talks about possibilities of prediction. Now let me talk about exploration. Why I want to talk about exploration is, as a space enthusiast, a space scientist or space engineer, I'm really fascinated by the ability to explore. Why is it so? Because way back when there was continents were there and people were going out into the vast ocean, traveling beyond the shores, trying to locate new lands, where they can go and migrate and create human civilizations elsewhere, they were not sure about where they are really going. Get into a ship, Vasco da Gama or Amerigo Vespucci, they got into their ships, they never knew where they are going. And thousands of them like that traveled and perished in the sea. And finally, they could discover some lands, the future lands, and then settled there and then created the changes. And it is true, nature, and if you read some of the books which have come recently, human beings have been traveling from Africa to the entire globe. And we also know the way they have traveled, thousands and thousands of kilometers they have traveled and explored the entire globe. And it is our natural behavior to explore. So now people are talking about colonization of Moon, Mars, and Venus. It looks something possible today, right? When somebody is talking about going to Mars, create habitats there, maybe move lakhs of people, create colonies on the moon or the Mars, or even go to Venus and float on the surface of the acidic clouds and stay there and live there. And even ideas of colonize on float or Venus has been created. Many are there. So when you read all of this, some of us, maybe the one generation before, may suddenly think that these are all too fascinating stories and may not ever happen. I think I won't go with them. I am very happy to go with those younger minds who will believe that it is one day possible, and we must make those, the initial attempts, so that maybe generations later we will really accomplish some of these feats. So let us look at why these planets are very interesting. Mars continues to become scientist, primarily because Mars is a planet which is more or less similar to, there is some animation there which is not running, don't worry about it. See, Mars has an advantage that it is almost closer to Earth's periodicity of, as far as the day is concerned. Its year is maybe 2 times that of Earth's year, but it has a gravity, it has a very thin atmosphere, and it also very interesting area to study whether once this Mars was a place where living organisms lived and later vanished, whether it will happen to Earth, or is there a way that we can create Mars into a place where human beings can once colonize. So there is still a lot of things have to be learned. So there are a lot of missions to Mars, and we are trying to explore that Mars much more. And all of you know, Mars Orbiter mission was India's first interplanetary mission. And we undertook this mission with great difficulty with the vehicle which we still had, the PSLV. The only 1,340 kilogram mass of orbit went to Mars, had a successful insertion and working still. I think that is the most interesting part. We had a Mars orbiter mission doing all the scientific explorations and a lot of publications and knowledge that came out of Mars. What are they? You know that it completed the designated life of 6 months on 24th March 2015, but still functional. And probably you all realize that going to Mars is not an easy task at all. Some of the highest risk missions that ever undertook by ISRO. Moving from Earth, overcoming Earth's gravity and traveling almost 6 months to reach Mars and successfully getting inserted is equivalent to throwing a basketball from India in a basket that is kept in US, and you so precisely throw it such a way that it falls into the basket accurately. So to that extent, the accuracy of navigation, mid-course correction if at all needed, and the sensor accuracy, all of this plays very important role. But for that mission, we also were very successful in getting a lot of data out of it, putting it in public, scientists coming and making use of this data and then publishing a lot of results. So I'm not going to those results because that's not the topic of discussion today. You also are knowing about many of those missions that happened last year amidst the pandemic. At least 3 missions were going to Mars. You know who are the people who sent those missions to Mars. But I was most fascinated by the perseverance and ingenuity, because it is a real ingenious way of going to Mars and then doing some experiments with a helicopter. Even the Perseverance had a host of equipments, even maybe tens of cameras of different nature to explore, understand the mineralogy and the atmosphere, and characterize them. And they were very successful in flying the helicopter. A helicopter or flying on Mars is really a wonder. Such a thin atmosphere. Without atmosphere, you cannot fly a helicopter. You know that, because you need some air, some gas medium to propel. and the wings have to fly, rotate at extremely high speeds, generate the required lift. Even with that lift, the mass is very, very small, and the time of flight was so less. It has to be controlled remotely with the communication delay existing between Earth and Mars being so long. So it has to be fully autonomous. And all this have been accomplished by some people. Very, very interesting engineering activity. Bob Belram is one of the very leading scientists in this domain. He has been working in it for a very long time in Jet Propulsion Lab as the chief engineer of the Mars Ingenuity helicopter. So we should all greet them for such a wonderful accomplishment. Let us look at Venus. Now, Venus is also an interesting planet because it is, look at the size comparison between Earth and Venus, almost very close. And the only problem with Venus is that its atmospheric pressure is tremendous, 92 atmospheres with 500 degrees centigrade there. So you can't really go deep into the atmosphere and try to find out. And recently, one of the physics groups review, I was listening to some of the scientists who are working in ISRO to look at atmosphere of Venus and understand how deeper, maybe 40 kilometers below above the surface and below, we really don't know what is happening there. Cyclones waging and acid rains happening. So understanding this is very interesting. It's equally possible that we can go and stay in upper atmosphere where the densities are manageable like Earth. There must be a very quiescent place. We can take some ships and stay. So some of these ideas like high altitude Venus operational concepts have been created by robotic explorations, crewed missions, and staying there. I really wonder why people make these ideas, that as if there is no place in Earth to stay, you go to such an atmosphere, very thin atmosphere on top of Venus, and then go and stay there. Now, all this will become very important only when we realize that maybe thousands, millions years later, this Earth continues to remain as a habitable place or not. So today, it doesn't appear to be very exciting, but it's technically really challenging. So please read some of these articles that you come across on how to colonize Venus even. Another interesting topic that is very important for human beings on Earth is the safety and security of Earth itself when there are possibilities of collision by asteroids. And this threat is continuously there. As if you look at the moon surface, it is continuously hit by many asteroids. So Earth also would have been hit in the past by many, and we know historical evidences of many of them, but these collisions can be very detrimental. But we know today, if at all such a collision is going to happen, how to escape from it, we know today, because Earth takes only 6 minutes to move from its current position to a new position of diameter distance. So if you know how an asteroid is coming towards us, and if we deflect it a little bit, it will go past us without ever hitting us. So using the known technology or rocket technology, we can impart that incremental small lateral velocity, which will move the asteroid far away. So we will save ourselves from the possibility of an extinction. Because the dinosaurs never knew this technology, so they perished. But why we should perish? Because we know it today. By this process, we can save ourselves. So we need observational capability. We should have propulsion capability. We should know properly navigate and calculate how to do this. So I think if nations comes together, this is possible today. Now let me look at some of the technology disruptions in not only in space. This I'll quickly go through because it is something that you all know. See, those people who went through the last of 30, 40 years, especially people like me, who realizes that many of the technologies which we're using today have really transformed the entire domain, entire framework of technology. For example, you look at the film. Probably your generation wouldn't have seen the film. Probably you wouldn't have ever read the dictionary. Encyclopedia, because encyclopedia is in your mobile today. And even libraries are becoming vanishing item. The way in which the transport sector has changed, the way in which the music production and distribution has changed, healthcare, medicine, hotel, food and consumption, procurement, even buying items, security, all these technologies have changed tremendously in the last of many years. And this is the type of the disruption happening. So the disruption in technology is also is going to change the world in this way. Some of the examples which I'm giving here in terms of computers, computers are today, got into everything, your watch, your mobile, your TV, all of them are computers now. In home also, you'll be able to integrate so much of IoT equipments. Slowly, these computers will get inside you. It will become integral part of human beings in your spectacles in your body, in your brain. Now they will be working to you to give knowledge, information, sensing, and logics to help you to work better, more efficient. Even entertainment, locomotion, even movement from one continent to another sometimes will happen through space transportation. Artificial intelligence is changing everything today. Even while we are discussing or presenting this, AI is working behind the scene to understand what we are really doing here, and measuring the way in which each of you are responding to these questions, collecting information, knowing, trying to know, and they will mark you with regard to what you are really doing. Even languages are disappearing because no longer we require different languages to be spoken, because computers can translate on the go. While I speak in English, you can hear it in any language you like if there is a proper translation software which is there online. So it doesn't really require to learn other languages. Possibilities are enormous in many of these technologies, which I don't want to explain one by one. But you realize that the transformation taking place in technology sector is so tremendous that unless you cope up with it in very short span of time, then you will become invalid. You are not usable to the society. So young people do realize it, and they are getting adapted to it. So look at the technologies that is moving at an incredible space: artificial intelligence, natural user interfaces, virtual reality, augmented reality, analytics in various ways, blockchain, robotics. I think these young people know it better, so I will skip it very fast. Artificial intelligence is changing in terms of recognition, identification, navigation, commercial activities, learning, personalized experience giving, etc., etc. Similarly, Industry 4.0 and IoT, probably you all know that the Industry 4.0 is in which the systems are connected so that you can work in a collaborative manner through the augmented instrumentation system, data collection, and intelligence in manufacturing processes. So it doesn't mean that where the machine is there, the workers can be anywhere else and program the machine to do certain activities, cloud-based data services, intelligent manufacturing environment, etc. So IoT is slowly emerging. Even in my house, I now have my pump which is working based on my connected. I can operate with my mobile, my camera systems, my bulbs and lighting, your TV. These are all programmable today. So they will get connected with the data flowing to the networks, and you will be able to analyze it. These are just the tip of the iceberg. Another interesting area is the energy. I think the way energy consumption is happening in this world, really going to change drastically. The carbon-based energy consumption pattern may remain for a long time because it is very, very important from economics point of view. But the investment renewables and others are increasing substantially, and we may taper down to such a point that the energy consumption pattern will change, which will make the conditions today much more benign in terms of the pollution. There are projections in either direction, but I would like to take the more positive aspect of this projection also today. So please try to learn how energy and its use is changing the society and how it will going to transform the economy. I think this is a very important element these young people should learn in the future. I want to tell you one of the interesting area which is also emerging for young people. Probably you are aware of manufacturing technologies in metal additive manufacturing. So 3D printing, sometimes you call it 3D printing, that earlier removal process is there in material removal process to material addition process. For example, when you build a house, you are putting bricks and then cement and concrete and build the house. So, but when you build something out of metal, what you do is to take a block of metal, you cut it out and then make the part. So we are going back to the house building concept in metallic materials. Take powders and then fuse them to prepare new parts. So your wastage is reduced, but there are a lot of technologies coming here. But it is not only in metal; it is actually getting into non-metallic materials. Your shirts, your shoe, your burgers, all will be printed in the days to come. So in the rocket technology itself, metal additive manufacturing has really transformed the way parts are realized. It can be done very, very fast. From the drawings to the product is only few weeks. Even engine can be produced with less number of parts. So it becomes very cost effective. The design becomes very efficient. So many new devices have come recently, which will actually change the cycle time required for new designs to come out. Even cars can be now manufactured much, much faster with this additive manufacturing. So this is another interesting area where young people can now slowly get into. There are a lot of technical side here, knowing about the materials, knowing about the manufacturing process, thermal analysis, stability, life, and so much of this. We have a special team in VSSC who looks at these technologies. Let me quickly go into some of the space tech innovations which are important. Globally, probably you are aware of that. Lot of travel happened recent times. Human beings started flying in Virgin Galactic, crossing the 100 kilometers. The Blue Origin people were going up and coming down. The new craft of the moon colonization, which is the Artemis program of NASA, taking shape. The new rockets are coming up, and in India, startup young people are started building rockets also. Probably. And another interesting thing is there is a large cloud of satellites, thousands of satellites in low Earth orbits are getting launched, which will change the way in which we communicate, conduct remote sensing, and this is becoming a big revolution. And another side, big players are talking about colonization. So these types of new approaches and thinking is happening all around the world. Please be aware of it. So, Elon Musk and Jeff Bezos, the stars of the space era today, the new era, they are businessmen who are IT business people who actually started investing in space technology and really caused revolution in the recent times. And they are the ones who talk about going to Mars. And many of others are following them nowadays. They are not following NASA or Russian or Chinese agencies. They are following these people, business people who have a passion to work in space, really. Another interesting area that's changing throughout is the application side of satellites. See, today we look at satellites as a delivery system, which is very instant. You cannot wait for asking for a photograph or image to come and wait weeks together to get it. Now you want it real time on your devices. And you not interested whether it is coming from satellites, whether it is coming from drones or from terrestrial imagery, and you need to be delivered very, very fast. Communication has to happen to individual, which is always connected. And you don't have to tell, if I go to phone, be connected if I talk. So to listen to that, they want communication throughout. Very accurate timing and positioning services are required. We also want to ensure that societal services, more and more digital, linked you are. So your daily life is connected by digital systems as a backbone. So no house can now live without a Wi-Fi connection. You also know the space is becoming very important as far as security, surveillance, and force multiplier effects are concerned. So understanding this is what the space technology in the future will really evolve. One example I'll tell you, drones. Probably you have heard about drones. But drones are now going to be used for various activities. One of the activities like this drone net technology, which we are working in VSSC. How can we fly drones and then collect the rocket parts while it is falling down from space? So I'm going to conduct one experiment in VSSC to collect a sounding rocket falling down for a payload of that falling down. First decelerate using a parachute and collect using a drone in the ship and going to the sea and bring back to land and see in small size. This technology can be perfected. Future, we may collect falling satellites or falling human beings from space and bring them to the shore. And there are new technologies coming up. Like just an interesting few things I have put in this slide. Self-eating rocket called autophage engines, which will eat its own body to generate propulsion. Another is materials which will vanish if you really don't want to leave any trace of it, called self-destructive materials. There is yet another material called bio-repair materials, which will solve cracks and defects which are coming inside, detect itself, and then correct itself. Another interesting is printing under zero gravity conditions. So each of these are some of the new technology development that is taking place within VSSC. I have listed them only because research is happening them in my center. So I am aware of what exactly they are doing, not really picked from internet at all. Now, a few more slides to show what Indian space sector is doing. Probably you are all aware, Indian space program has been an excellent story of success in terms of its missions, launches, satellites, technology missions, and supporting global launch services, and also doing a lot of scientific missions like Chandrayaan, Megatropics, NISAR, future missions, and collaboration with the foreign nationals. But we are also looking at future human space flight missions. And all of you may be wondering why human space mission, and probably in the question and answer session, we'll address this. Why Gaganyaan program, and what is that we are going to achieve by Gaganyaan program as a long-term perspective with respect to space program. I think this is very, very important. Young people must really take the spirit of the whole activity and take the pride and prestige associated with that. But what really we are going to gain by working in human space program is something very important. Each one can have its own views, so I don't discuss here because young people like you can definitely form very strong views on it. So we will discuss later. I also want to show you that our launch vehicle array is really splendid array. The first of the 3 launches is something that we are working on, but the remaining many are the ones which we are currently in development. SSLV is something which we have almost reached development, and we are trying for a launch this year. We are working on a reusable launch vehicle which will go to orbit and come back. The test vehicle, we have already completed the development, and already the first vehicle is almost ready. We are working on a vehicle called Admire, which will go up and vertically land. We are developing the human space flight vehicle, LVM-3 human space vehicle, and the heavy lift launch vehicle and the heavy lift human spacecrafts are really in the idea stage today. But I'm sure one day we will be getting the funding from appropriate agencies for us to proceed with these developments. Now look at some new space activity. Recently you are reading about what is happening in this country with regard to space activities. I only want to give you a glimpse of what is really in discussion. So today, space activity today is handled by ISRO, by government, and the typical money involved is about 14,000 crores. So there is a general feeling that this money and the activity has been really constant over a certain period with small increase in its outlay. But this is not enough. We need to increase it substantially, looking at what is happening all around the globe. So our target is something like 50,000 crore worth of Indian space economy should happen in the coming days, and how we will really make it happen. So the idea today is ISRO should work on technology enabling the role, and industry should work on business and marketing and creating more and more financial outlay for this program. How to put space program into utilization. So this is one important task which we are discussing. And for that, there is a new direction from government. ISRO will continue to be the space technology harbinger of the space technology, looking at new ideas, new developments, look at national missions and participation and handholding of all those space actors. Whereas in space, it will be a regulator to support new actors to come inside, and with the support of ISRO and ISRO facilities, they can bring up launch vehicles, satellites, and applications. And NSIL, New Space India Limited, is a public sector undertaking which will own some of the space assets, and it will generate the required funds for this activity to grow, work on industry mode of production. So together will be the new space enterprise of India, ISRO, InSpace, and NSIL. But there is another important actor called industries, startups, and they will become one of the prime support system, which will really drive the first 3 pillars to make our Indian space program really move forward. There is a lot of opportunity for young people. Remote sensing and data services is one thing where tremendous amount of commercial opportunities exist. The data from satellite is available, and how to convert the data from satellites into useful products for various applications. And there are people sitting here in this talk itself, they are listening to me, who have a great amount of expertise and practical wisdom in how to convert this data into useful area. And India has done fantastic job in lacing with a lot of departments of government of India and public to show how it can be made use of. But of course, a lot more can be done with new startups and new developers coming into this place. Building satellites for commercial activities, another big activity. Small satellites are being built by universities and colleges, but that's not the point. I am talking about large number of satellites are required to meet the emerging market, and how new industries can start build this market based on market demand. Sometimes tying up with private industries from outside, manufacture within India, and then launch using Indian satellites. This is another important opportunity. I want to tell you, young people, there are a lot of startups in India today. 50 startups I know. There are startups in rocket design. There are startups in subsystem realization testing of payloads of satellites, space-based application development, remote sensing data, products and value addition. All of them are, some of them are really good funded, and some of them not funded that much, but all of them have started working with great amount of passion. So young people must be aware that this is happening in this country, and many of you sometimes may become CEO of one of these startups. I am very sure about it. So I want to tell you as a final slides, that Indian space enterprise, where earlier it was only ISRO and industries who is supporting them, but now it has to become big industries, startups, and ISRO working with this the whole enterprise, which will really enhance the space activity in this country. So let me summarize the topics which we discussed. See, the space tech is not independent of itself. It is actually evolved by the disruption of technologies, which I have discussed. Artificial intelligence, robotics, IoT are actually changing additive manufacturing. These are changing space technology also. New players are emerging in private sector. New services are created which are very space-based with more affordability. The launching per kg to orbit has become much lower cost today. Human travel to space has been now democratized. That means even astronauts, non-astronauts, common people can now travel with very little bit of training, which has already been demonstrated. And exploration is naturally human. And we need to sustain this nature and don't tell that only robots can go. And we have to prepare in core technology areas like materials, manufacturing, create business opportunities in space-based services, and support and encourage startups. And we can be a great destination for space tech if you people and all of us prepare for the future. So thank you so much. And I'm very sure our world in 2030, I have taken only 2030, can be even longer. So we need to be a technology-based nation and with great progress in all domains, including space technology, for us to really grow. And for that, we need to start, incubate new enterprises, tech-driven companies, customer service orientation, skill-based learning and education, and self-reliance. I think this is what is important. With this, let me stop this talk and I will take my next assignment of releasing the e-magazine, if you permit me. So thank you so much. Thank you.
Sir, thank you very much for the brief yet vivid, invigorating and lucid glimpse of what the future beholds for the space industry in general and ISRO in particular. This is a great experience for all of us, and we are all enthralled to understand and listen to you. Only we wish that we had much time with our disposal, and we are so grateful to you for sparing your time under your busy circumstances. So thank you once again, and we all wish and pray that under your dynamic leadership, our country will make all the necessary strides into the future, and definitely we will reach the pinnacle of achievement. Thank you, sir, once again. And now may I request you to officially release the version 2.0 of our Stellar Chronicle. Varun, can you?
Yes, sir. I am listening. Sir, is it visible, sir?
Yes, it is visible. Sir, I request the director to formally release that.
Thank you. So I formally release your next issues, second issue of the Stellar Chronicle by the UL Space Club. I wish all the editors and especially the mentor editor as well as student editors a great congratulations, and let this produce the result what it is intended for. Thank you so much.
Thank you, sir, again. And we have about 10 minutes of time for interaction from students. And I request the few students who have some, you listen to Director Somnath, sir, and the relevant questions can be asked now. We have got 10 minutes. Please.
So Bharat is here for that.
Yeah, Bharat, please.
Am I visible and audible? Please tell me first.
Yes, you are.
Yes, Bharat, you are clearly.
Time is less, so you please go ahead.
Thank you, sir. Dearest and most respectful Somnath sir, respected Sreejalekshmi ma'am, Kutti sir, Jairam sir, respected veterans from ISRO, friends from UL Space Club, teachers, and dear friends. We at UL Space Club are extremely humbled at the fact that we've been able to speak and interact with one of the greatest space scientists of our time. In fact, UL Space Club has always been happy with the fact that we've been able to interact with Dr. Somnath in 2019. And I personally had the opportunity to speak with him. And it is something that I would cherish throughout my life. We don't have a lot of time left, so let me get into the question and answer session. So the first question, of course, related to something which has had a global trend right.
Bharat is having network problem.
Because globally, we've seen the trend of companies like SpaceX. Am I having an issue? Hello, hello, hello. Am I not visible? Hello.
No, it's okay.
No,
No, it's
Bharat,
okay.
there was an
No,
issue,
what
but
you
it's
do, Bharat,
it's
is
okay now.
Carry on,
Okay,
Bharat.
okay, okay.
Carry on,
Okay.
Bharat.
So let me-
Carry on.
Bharat, you switch off your video.
So- Okay, sir. Okay, sir. Sure.
Yeah.
So globally, we've had the trend of private firms like Elon Musk and SpaceX, Blue Origin from Jeff Bezos, and even Richard Branson's Virgin Galactic coming into space science and technology, and of course, accelerating the growth of space science unlike ever before. And of course, with the government's new approach
Bharat,
of
we have
space.
lost you.
But even then,
Yeah.
the public don't really have a clear-cut idea of. Am I audible? Am I audible?
Yeah, you come to the question
Yes, yes.
faster.
Okay, so even then, we don't really have a clear-cut idea. The public doesn't have a clear idea of what it really means by privatization of space. So the first question is from Adil. Ask you,
Okay.
sir. So what should we expect from the privatization of space sector in India? And can we see ISRO collaborating with space?
I know. First, let me tell you, there is no privatization.
And what is the
of space.
perspective of ISRO?
Yeah, there is no privatization of space sector in India. It is a wrong notion. See, just now you heard Air India privatized. Air India has been taken over by Tata. There is nothing going to happen in space sector like that. What we are talking here is that ISRO, as a national organization for space activity, has been working here for last 50 plus years. So that is one. That is continuing, and this will continue to be there. Now, what we are going to do is we need space technology-based companies to happen in India. They are not there today. Let us realize that. See, suppose you go to US, you will find that there are a lot of companies who is having technical capability today to design, develop rockets, design, develop spacecrafts, or even look at applications. But we are not telling such companies will come immediately. It will not happen immediately in India because it has a different historical development. For example, those companies started working in defense sector and they slowly got into space sector. And space sector continues to remain as one part of their business model, and they do that. Whereas in India, we have a lot of companies working for space sector, but they are still suppliers of parts. And ISRO happened to remain as the integrator or aggregator of this, who coordinates all the efforts and then finally make a launch vehicle or a satellite or an application. So this is the model currently. And we are trying to build such a way that now the new players in private sector can take up higher levels of responsibilities. Like, can they build the rocket themselves with the hand-holding from India, Indian Space Research Organization? It doesn't mean that they are going to make it 100%. Still, it will not happen because there are still a lot of tacit knowledge within the organization which cannot be shared, which will not even go, which will not even be acceptable by them with the capacity which they have. So it will take a long time. But we are making a first-time attempt by which at least the production work can be done by this party so that we can reduce the workload in that direction within the organization. This is one side. Second is, there are a lot of startups which are interested to build capability in this. They are not immediately going to build PSLV or GSLV. They cannot reach up to that level. So they are starting with small rockets, which are maybe or SLV3 class. Okay, let them build it. But they cannot also build with that type of knowledge and skill available within them is also limited. So it is also a classified information and knowledge, So we need to handhold them, help them to build their capability. So ISRO is now opening up to enable people who are earlier wishing to do many things. Why don't we help them to do it? Because it's all done in India, our own people. So we cannot say, I will keep it within ISRO and then not allow anybody else to do it. So there may be outside better people, enthused people like you, youngsters, wishing to do new things. So we will now enable them to do futuristic things. So this is one part of the story. Second is, there is huge amount of applications. Space is actually very challenging today. Reusable rocket has now brought down the cost of rockets substantially. So how do we really bring about cost benefit to the launch side, cost benefit to the satellite, the communication revolution which is happening outside? How do we bring it to India? How do we really reach the services to larger segment of society as we did in the network as we know today? So these are the questions being asked. So basically, it is not privatization, I want to tell you. Private people are allowed to work on space, and that will be regulated by the new mechanism which we are going to do. Because space activity cannot be allowed to happen like every other industry. It has to be regulated because it has various other international repercussions which are involved here. So it is a regulation mechanism we are bringing in. We are also telling ISRO will handhold you, support you to go to the next step. That's what is actually happening.
Thank
Am
you
I
so
clear?
much, sir. Yes,
Okay.
sir. Thank you so much, sir. In fact, this answer from you is something that has to remove a lot of false conceptions from people living today. And in fact, the next question is something that I found to be extremely important. Sir, right now, we all know that a huge issue that space scientists like you face today is the presence of space debris and the fact that it has been affecting the launch of satellites and other space missions throughout. So we've seen other space research organizations like ESA coming up with ingenious ideas like Clear Space One, and even some ideas where they create webs to collect space debris and launch, like move it down into atmosphere and let it burn. So a question from Manasa has come, and she's asked you, sir, what is ISRO planning to do about it? What is ISRO currently doing about it to solve this current issue of space debris?
So there are multi-pronged approaches are there. One is regulation. Second is activities for mitigation. And the third is that you create an international understanding about this problem. So, okay, all three domains we need to work. First, on whatever we are doing, why we should be responsible people. Like we don't litter public roads, you should not litter space also. So for that, you need to do certain things. When you launch your satellite, make sure those satellites at the end of life, you move them to either graveyard orbits or you will deorbit. This is one responsibility each one is have. So you declare the responsibility and do it. That is one part of the story. Second is whatever stages you are sending to the orbit, like satellite, the upper stage of a rocket also become a debris. It must be prepared so that it doesn't explode. So that we are already doing from last so many missions. We vent all the fuel fluids, make sure that it doesn't explode. So this we are doing, but over years only it will come back. It cannot be brought back immediately. Next thing what we do is you should work with the others with regard to observation of debris. So first of all, you need to track them. Whichever are visible, it must be tracked. The catalog of data must be shared so that you prepare for any possibilities of threat to our operational system. This must be done. So this is being done, and we have established our own network and collaboration with others to track them, catalog them, develop software so that we can study them, so that our missions and activities are safer. Also, there are international activities which is trying to bring about more awareness and responsibility for each actors, like putting auxiliary propulsion in satellites so that at the end of life they can be triggered to move it to the graveyard orbits or can be used for deorbiting. This is another activity. Even regulating launches of satellites to specific orbits by which the threat part is minimized, because there are different altitudes, low Earth orbit, medium Earth orbit, GTO, where the dangers are different. For example, where the ISS is there, we need to generally keep litter free so that human beings orbiting that zone should be very safe compared to other zones. So these type of regulations we have to bring about in international bodies and try to implement them with the time passing. But probably you realize that this is a very costly affair, because it is not easy to make others fall in line. It is not our satellite alone, because there are a lot of nations, and every gauge of propellant counts on the life as well as return of investment. So there is a difficulty there, but it is through international efforts that we will be able to do this. But let us do our part so that we can really do the advocacy in the national fora. So that is international fora. So that's what steps that we need to take.
Thank you so much, sir. I hope that you've heard Varun and Abhinav give you a brief of what we do here at UL Space Club. In fact, right now, the student members of UL Space Club are coming up with new projects. And in fact, we have multiple projects running. And so on behalf of all of us here at UL Space Club, I would like to invite our team lead, Varun, to ask you a question regarding the activities that are to be done from our side, and to please give us an idea of and give us an advice of what we should do in the future. So Varun,
Okay.
please come forward and ask the question.
Okay. Thank you, Bharat. Hi, sir. So what are the possibilities for a group of students from UL Space Club to develop a space tech team and to involve in a real-time space-related projects like nano-satellite payload, rockets, etc. And I have one more question related to that. So, the student fellows of UL Space Club have already started a space tech group, which is named as Team Gravitons, to involve in real-time technical projects, and not only space and type of technical projects. Even when we are having academic limitations, because most of the students are from higher secondary and few of us are graduating students. So what's your message for our projects and for our team?
Okay, in this case, I will give you a practical answer. Okay, rather than see, all of you are aware of space technology and what all things are involved. And many a times, a practical project of this nature is a very involved project. You know, it requires knowledge and skill in various domains of science and engineering. Maybe in a school level, it will be one difficult thing for you to accomplish. So you, with a lot of support, probably you'll be able to do. But what you can do is do small experiments. So I can give you one clue, because you need to have fundamental, some electronics knowledge, some software knowledge, and some building knowledge. If that is there, I can offer you orbital platform or PSLV for conducting experiments. So this is a very low cost platform. You don't have to build the entire satellite. Okay. You can build a very small electronics package, which will do some measurements of space. So you first explore what exactly the type of measurements that you can do, what type of data that has to come, and what science you can do with that. So please study that, and you can build a very small card or an instrument or a sensor, and we will give you the power, we will send you the data to the ground. All that you don't have to worry. That we will manage within PSLV. And it will stay in the orbit for maybe months together, because we are now planning to put batteries which will work, make it work for a long time. So 1 or 2 experiments of this nature you do as a beginning. It will not cost you huge money. It can be done with less money. So that is the first suggestion I have. Second suggestion possible is that you can conduct experiments in sounding rocket. We are also having the sounding rocket launch every month. I can put some payloads in the sounding rocket to conduct measurements in atmosphere. There are a lot of studies being done with regard to atmosphere. When it is dropping down from the altitude, then it can conduct data, collect data, and then beam it to the ground station. We can use it for science experiments. For that, 1 or 2 of you should go and study what exactly are the domains of these measurements, what area there is a possibility to do additional measurements, what is the science part that will come out of it. If you know that, we can build it. I can assure you that we will support it from VSSC, how to build that equipment using the electronic circuit you designed. I can review. We can help you in terms of constructing it so that you can not spend too much of risk of how to do that. What also have to be followed while designing and making it for a rocket flight. This can help. This I can tell you. Third, I will tell you is not building anything purely on application side. Say there is a huge amount of potential with satellite data which is freely available. Can you try to develop some applications using satellite data? This probably I may not be the right person. Jairam sir is there, so you can discuss some of these people to do a very primitive prototype model of how to do a satellite data based application page or application system which can be posted load, so that many young people will really understand how to really use satellite data and how to create value for it. And once you really go through it, probably you may have better idea than our veterans here. So I am very sure about it. So these are 2-3 suggestions which I can give you. Convert this, maybe debate internally and come out with some good ideas. We are here to help you.
Thank you, sir. Thank you so much. And we hope all your blessings with our all activities.
Thank you so much, Varnata. Thank you so much, sir. Thank you so much. We know that we are having a little bit of an issue with time. And of course, for ISRO, time is everything. So I would like to conclude this session right away. And I know that a lot of you have a lot of questions to ask us. And we can discuss all those questions in our other platforms like Cosmos and Team Gravitons. And if there are other questions that you would like to ask us, you can ask us through our platforms. And even you can email us, and our email ID will be provided to you in the chat box by Varun. If there are questions that we cannot solve out internally, I hope that Somnath sir will be kind enough to answer those questions for us. That is something that I would wish from you, Somnath sir. That is something I would like to request from UL Space Club side. Without further ado, I would like to invite Varun to please move with further proceedings. Thank you so much.
Thank you, Bharat. Thank you, Somnath sir. Thank you for a wonderful talk and answering our questions. So I think let's move on to the presentation of Dr. G Sreejalekshmi from IAST.
Varun, just one
Yes,
second.
yes.
Just one
Yes.
second. Just 1 second. Sir, Somnath sir, we are extremely happy that you have taken time from the midst of your very, very heavy schedule. I know about that. and giving a good talk here and exciting our students. And your VSSC's program of International World Space Week celebrations, many of our students participated. 32 students from Kerala got into the quiz program, and 4 of them are from our club. And we cut short our programs of World Space Week after talking to you, sir. You told that you are going to have the program and it is coming out, and we waited for it. And we wanted to have our own quiz and few other programs. We just did only 2 programs with the highlighted. One is webinar in schools. We arranged it, and a Skywatch. So the rest of it, we didn't do it because our students can participate there. Thank you very much, sir. Once again.
ക്വിസ് പ്രോഗ്രാമിൽ ഞാനും ഉണ്ടാവും. ഞങ്ങളുടെ കൂട്ടത്തിലുള്ള സീനിയേഴ്സ് എല്ലാം ഉണ്ടാവും. എന്റെ ഒരു ചോദ്യം പ്രതീക്ഷിക്കാൻ ക്വിസ് ടീമിന്. ഞങ്ങൾ എല്ലാവരും സീനിയേഴ്സ് ഓരോരോ ചോദ്യങ്ങൾ ചോദിക്കുന്നുണ്ട്.
Very nice, sir. Very nice. Thank you very much, sir. Thank you, sir.
Okay. Thank you so much.
Thank you, sir. So with your permission, yes, sir. With your permission, let me move on to the presentation of Dr. G Sreejalekshmi ma'am. So before going to Sreejalekshmi ma'am, let me introduce her to the followers of UL Space Club. Dr. G Sreejalekshmi is from IAST. She joined IAST as a founding faculty in Department of Applied Sciences. And she's an associate professor now in IAST, and she has a PhD from Kerala University in chemistry. So we are very happy to welcome her to the UL Space Club valedictory function of World Space Week celebrations 2021. So before going to Sreejalekshmi, I just want to mention one more thing that Sreejalekshmi announced to us. And we have already announced to our followers and all the schools when we were interacting with the students of that school. That opportunity was the school students have an opportunity to submit their idea of an innovative experiment in space life and in astrobiology or life into space. And that topic, they can submit their own ideas on an innovative experiment. And the selected students will get an opportunity to work with Dr. Sreejalekshmi ma'am to conduct microgravity experiment and payload experiments. And one thing that is, we are very sad that it was only for school students. So it's like an exciting opportunity, and we are very happy that our UL Space Club members got such an opportunity. So thank you for that, ma'am. So without any delay, let me welcome Sreejalekshmi ma'am for having a wonderful presentation on life into space and introduction to space biology. Ma'am, over to you.
Yeah, thank you so much, Varun. I hope I'm audible to all of you.
Yes, ma'am, yes.
Okay, let me just share my presentation and see whether it is working in the full mode.
Sure.
One second. Yeah. Is it coming?
Yes, ma'am,
It is coming. It is coming.
Okay, in full mode it has come, or
no, ma'am, it's not in full mode.
Now?
Not yet, ma'am.
It is.
I'm seeing it here in the full mode, so I think Somnath sir.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes.
Yes,
it's full mode now.
It has come.
Yes, yes,
ma'am.
yes.
It has come well. Come well.
Yeah.
Yes, ma'am.
Okay. So at the outset, I wish to extend my warm gratitude to all the UL Space Club members for extending this a great opportunity to me, and the most respected director VSSC and director IAC Somnath sir, Kutti sir, then all the veterans in the space arena and in their own domains of research, whoever is present in this particular meeting. It's a humble bow from my side, and to all my students who are attending this session, I'm really, really glad that you were enthused by whatever the small sort of opportunity that I was extending to you. Okay, so in this particular talk, from where Somnath sir left us with the exciting opportunities in the space technology arena and the upcoming entrepreneurship and startup-related opportunities coming up, we are also having one more huge challenge with the recent announcement of the Human in Space program. Okay, so in that context, we are actually entering into a new domain of space research, that what we call as space biology. Okay, so in this today's lecture, maybe around 30 to 40 minutes or so, or maybe even lesser than that, I wanted to take you into the world of space biology, where we are actually taking life into space. Okay, so the domain what we call is space biology. As you may be knowing, I am representing Indian Institute of Space Science and Technology. My institute is actually a teenage institute, like most of you. We are only 14 years old, but the institute was set up under the auspices of Department of Space, Government of India, as an autonomous body, and we are having the deemed to be university status. With 7 academic departments and 102 faculty members, with more than 300 research areas that we are exploring. We are actually a small institute with a very vibrant and dynamic research environment. Okay. So, and I wish to dedicate this particular lecture to all the curious minds who are attending this lecture and who are part of this UL Space Club. And all the mentors, I actually want to thank all the mentors who are acting as strong pillars to support the enthusiasm of the students, which is actually not that easy. As a faculty member, as a teacher, I know that difficulty. Okay, but you are all voluntary taking up that job, that assignment means that is a lot contribution from your side. So as you all know, we are celebrating. So celebrations are always occasions of joy, and along with the celebrations of space, whatever happened in the previous episodes. So we are currently in the year 2021, where we are celebrating women in space. So rather than celebrating women in space, we can go to human in space. We will celebrate the humans in space, right? And along with that, we also, I also wish, or I also greet you on the occasion of the Azadi Ka Amrit Mahotsav, the 75-year of independence celebration of our own country. Okay, so with that, these are the different banners. If you go to this particular site, World Space Week Association site, you will see different versions of Space Week celebrations were dedicated to many of the themes. So I was interested, I got interested in knowing why we celebrated past episodes, and it was rather encouraging to see we celebrate space for many reasons. Okay, so moving further, what's in store for you today? Okay, so as I mentioned, we are actually trying to send out life into space. Most important thing to notice, we are trying to conduct space life science from Indian soil. Okay, so when you compare the global scenario, the space life sciences actually started its journey long back in the 1940s. But our country is actually starting it in a serious mode because we have already announced that human spaceflight programs. So in a way, we have to now equip ourselves to meet the demands of the space program, and also to equip or also to enable the sustenance of the program, which is more important according to me. Okay, so that is why I thought of discussing with you students, and I am targeting the school students mostly in this particular lecture, essentially because they are going to grow into the bigger or maybe experts in certain new domains which are coming in. Okay, so I will be telling you, or I'll be just briefing you about space life sciences, the components currently which are making that particular domain. Then in that context, we will be considering space as a laboratory, and space as a laboratory, especially to conduct life science experiments. And if we are considering the life when taken into space, obviously you all know there are several challenges. Okay, so when challenges are coming up, then of course we look into how to overcome those challenges, right? Then ultimately we find that we are able to solve many problems. So we have a human nature is to turn these challenges into opportunities. This COVID time is one among the greatest demonstrations of that human quality, isn't it? So after that, I'll be telling you with some example from our lab how to design a spaceflight life science experiment. Okay, and then maybe in between the presentation, you'll be seeing some glimpses of space life science experiments which are already ongoing. Okay, so at the end, I would also tell you about some of the prospective as well as opportunities which are upcoming in the area of space life science research. Okay, so when I'm talking about this particular topic, you can see some puzzle pieces also I have put here, right? So
the slide is not changing.
Can you just put to presentation mode? Yes.
Now it is the second slide. What is in store you are seeing? No?
No, ma'am.
No,
It's not in
it's in
presentation
the
mode.
first slide.
It's in the first slide. It's not in presentation mode. You just put it in presentation mode.
1 second. I need to stop sharing and then go back, right? One more time.
No, ma'am. You can
You
open
just
the
minimize the screen.
slideshow option there.
Now you are seeing it. Second slide.
It's okay, ma'am. But
Yes, ma'am.
can you go to slideshow option? Put it in a presentation mode.
Yeah, 1 second.
Ma'am, if you can press F5 with
From the current slide, ma'am.
not
From the current slide.
From current slide.
Yes, ma'am.
Is it coming now?
No, you can you just minimize that tab? Then it may come.
Now which slide you are seeing? Can you please?
Slide
what's
is
in the
good
store?
one. But
What
it's
is in store, right? Yeah, I'm currently in this particular slide, but again, when we are going into the full mode,
No, ma'am, we're not yet into.
Can you present it, ma'am? From current slide. You could just,
Ma'am, can you please press on that small icon that you can see over there?
which
no,
one?
yeah.
Beta?
So current slide. Current slide.
This
From
one,
current
no?
slide. From current slide.
From current slide, yeah.
No, the other one. Yeah, that one.
I clicked it. It is coming in my side, but I think now you're seeing the second slide?
No, ma'am.
No.
Ma'am, we are seeing the second slide, but it is
Ma'am,
not in full screen.
Not
No,
in
no,
the
no. But
presentation mode,
it's a
it's
technical
not in the
problem.
full
No,
mode.
no. Ma'am,
Yes?
no, ma'am. You can do one thing. You can just click that button just right of the minimize button. Can you just do that? Can you just click the button? Yeah. Then present it.
Minimize button.
Ma'am, I think you are presenting a window only, not presenting entire screen.
1 second.
Somebody else is supposed to.
Oh, you want me to present the entire screen? I'm sorry for the disturbance here.
Yes.
1 second. I will
it's
share
okay.
the entire window. That is what you wanted, right?
No, entire screen, ma'am. Entire screen.
Entire screen. 1 second. I'll just move back and come back again one more time. I'm really sorry for the disturbance. And now I'm sharing the entire screen. Okay. So I have to open my presentation first. Then only you can show that entire screen, right? Or else please wait.
No, first you can share the entire screen, then you can come to the
Got it.
presentation.
Let me see. That share option is not working. I'm clicking it. You can see that I'm clicking it.
No, ma'am. You didn't share the screen. Can you just once more share the screen first?
Yeah.
In the meet.
I gave entire screen. Okay. Then I'm clicking on share, but it is not allowing me to share that one entire screen. That's the problem.
First, you select the screen to share. Select the screen.
Yes,
There is a
select
screen
that
in that.
picture
Just
in
click
that
there.
window.
Keep on doing
There
this.
will come a pop-up from the above. There will be a screen inside it. You just click it and share.
Yeah, that everything. That was done. Yeah. Just there. 1 second. Now you are seeing my screen, right?
Yes,
Yeah,
ma'am. Yes.
yeah. It is coming.
ma'am.
It is coming.
Coming.
Screen
Yes,
is
ma'am.
coming.
Yeah. So now I have to open my presentation and just
Yes,
confirm
yes.
whether you are seeing the presentation
Yeah,
now.
yeah.
Yes, ma'am.
Yes,
Yeah, it
yes.
has come.
Now it is in the full
No,
mode,
yes,
right?
no,
Yes,
it's
ma'am.
okay.
Yes, ma'am.
Yeah, we
Yes,
solved it. We solved it. Great.
Yeah, you are back. You are back.
That's good. So I was talking about, we talked about puzzle pieces and the one puzzle immediately came up, right? But with the joint effort, the collective effort, we were able to solve it. That is exactly what is shown over here.
Excellent.
So
Teamwork.
whatever problems we are facing, if immediately we have a network of people who can actually guide you through that process, definitely we can build beautiful structures. Okay, that is very much true in the case of research as well. Okay, so currently we are talking about space life sciences. So as I mentioned, it's a huge collaborative effort which is happening throughout it's a global effort. Okay, so minimum these many agencies, 7 agencies are currently working hand in hand to function. Keep the one of the space stations functional. Okay, so let us move into the presentation and see what all things actually we can explore, or what are the things are being currently explored in the context of space life science research. Okay, as you can see, for my school students here, young small friends here, I'm just giving one definition. So what is space life science, if somebody is asking you, because you may be starting to work in space life science research very past, then you can tell that you are going to study the biological as well as biomedical processes happening in space using live specimens. Okay, so you will be taking live experimental subjects, and then you will be studying them, the changes which are happening. And in that process, you are going to utilize the space as a laboratory. That is something very exciting, right? So you are going to conduct experiments which are having space environments, or maybe even the real space you can go and conduct. Okay, so this domain, as I told you earlier, it was not that very recent thing. It is something old which happened. So in early years, whatever people were trying to do was to assess the ability of the living organisms to survive the space flight. So what happened that initially there were in the 18th century and all, there were balloon flights which happened, where live samples were taken. So if you people are following this space biology experiments or experiments using live specimens, you should be knowing that the first space travelers, documented space travelers, was a trio. One duck was there, one rooster was there, and one sheep was there. Those three people were happily traveling into space, but the vehicle which carried them was actually a balloon. Okay, so scientific ballooning is one among the probable areas that you can explore. I will discuss about them in the upcoming slides. Okay, so from that early years of experiment, currently the subject has reached at a certain level of maturity, so that currently what we know about these experimental subjects, live experimental subjects, is that both animals, humans, and along with plants, they are able to withstand. Currently, with the vast amount of scientific data, accumulated scientific data over these many years, currently we very well understand that the human or the live subjects are able to withstand the exposure to microgravity. Not only that, with some of the protections, the cosmic radiations, we can come back, and even the rigors of launch and re-entry by the careful, design of the spaceflight vehicles, and the built-in what you call as spaceships. Your spacesuit, it is actually a spaceship, isn't it? For a customized spaceship, we can call it. Okay, so with all these utensils or all these supports, now we know that life can survive in space. So from that mere knowledge of the probability or the possibility of existence of life in space, we were more encouraged. Okay, so from that big experiments, or what you call as macro level experiments, the current focus is actually on the biological changes which are occurring at molecular levels. Okay, cellular level happened, then currently it is focusing on molecular level changes which are occurring during the flight as well as after space flight. So this is the area in which we are actually entering into the domain of space biology. So by that I mean that there is already a lot amount of research going in. So we have to enter into this domain, and we have to establish ourselves as a critical link in the biological research continuum. Okay, so space life science continuum, we should be able to, India should be able to enter into and make ourselves as a critical link. Okay, it has to be a critical link, without which the space biology programs, should feel a void. If our programs are not there, they should feel a void. So that is the responsibility with which we have to start working in this particular area. Okay, so over the years, human body has been subjected to several of the research. Plants were done, used for research. Food processing, agro-processing is one among the big areas where the research is still ongoing. Then different animal subjects, we call them as whole animal models, or experimental subjects, genetic models we call them. And apart from that, even currently people are trying to have the concepts of building habitats in elsewhere or extraterrestrial bodies. Okay, so these are all actually coming under the space life science research. So when we consider space as a laboratory, the first question emerges: where does space begin? So when we talk about space in the context of space biology, I would like to highlight something very important. We are not talking about the Kármán line. We are not talking about the 100-kilometer altitude, as the aeronautics people are talking about. But when we talk about space biology, we are talking about the physiological space. Okay, so the physiological space is documented to start somewhere near 18.29 kilometers of altitude. The reason is that beyond that particular point, it is proven that the human body or in general, life cannot survive without the support of an artificial system. But that is why, because we are capable of building an artificial system. That is the reason why we are able to take the samples beyond what you call as this 18.29 physiological space, beginning of space, right? So here, the point I wanted to bring out is that we cannot assume that the space laboratory starts arbitrarily at a point just above the surface of the Earth. No. If somebody is asking you, this 18.29 kilometers is something very, very important. And even beyond that, there is some amount of atmosphere, some amount of pressure, everything is there. But in order to survive the life without an artificial support, it is not that good. Okay, so that is why we call that as this physiological space, and this is the laboratory where we can start exploring the research on space biology. Okay, so for this particular purpose, even we can consider our space for this particular topic to be considered to be just after or just beyond the biosphere. So you all know we are having biosphere, which is the components which are the atmosphere, the hydro and the lithosphere, right? So we are all happily living here. But at the same time, we want to go to space, we want to explore space. That is what in Somnath's discussion he was telling. We are actually the inquisitiveness of human mind. We want to explore whatever we don't know, or we want to be challenged every time. Okay, so in general, if you talk about space life sciences research at its very root, we will find that basically two generic objectives are always addressed. So the first one is to have an understanding of the effects of the exposure to microgravity on biological systems. Why we are more concerned about microgravity is because you will be knowing that when life emerged approximately around 4.2 or 4.3 billion years ago, we were actually born into a system which is happily holding us on ground, right? We had a strong footing because of the existence of this, what you call as the 1G force, the gravitational force, right? So we are pretty sure that when we are leaving the Earth's magnetosphere or the Earth's orbit, then immediately we are deprived of that 1G force. We are deprived of that stabilizing force. So when all the body evolved with respect to that particular directional force, when we are taking off that directional force, obviously we can expect there are going to be changes, right? So typically the biological systems are very highly affected by the exposure to microgravity conditions, or sometimes people call it as zero gravity conditions. So in the context of space life science experiment, we are trying to understand what are the effects of this exposure to microgravity happening on biological systems. So why should we understand that? Only when we understand the problem, we can actually devise solutions. Okay, so what is the solution that we want to bring in? The solution is actually to have methods or techniques to reduce the risks associated with human space flight. Okay, the manned space flight, that term has to be changed with human space flight. Okay, so and apart from that, the second objective is that using the microgravity environment, there is always a possibility that you explore or you come across the so-called breakthrough sciences which can come about, and we can actually broaden the knowledge in the particular context or particular realm. Okay, so that is the one more important aspect of the space biology research. Okay, so as I mentioned, this is just to tell you that the history tells us dates back to 1946. Okay, when people started using the balloon flights for conducting space life science experiment, and in that experiment, whatever you are seeing here in the third column, no? You see the first experiment was in order to assess the effect of cosmic radiation in the upper Earth atmosphere. And the biological samples used in the study were fungal spores and fruit flies. You see, fruit flies I have highlighted. There's some secret behind it, I'll tell you. Then so many other rocket launches were there. Then again, this balloon flights. Then we are having short missiles were used. So many platforms were used. And this research article I have listed over here, it gives you a complete list of whatever historical, I mean, in chronological order, what all things happened and what are the aims of the experiment. So why I am showing this is because if somebody is interested in starting to work on space biology, we should be always knowing what happened or who traveled before us, right? So those parts of whoever has set that can be utilized as a good platform to start your own research. So literature survey is actually one important component. We should be knowing what has been done earlier, but at the same time, we should not be restricted or limited by the imagination people were having in those days. Okay, you can refer to those things, but never get limited by the imagination of somebody else. We are all unique, right? So just use that uniqueness in you, and you then design one experiment. That is going to happen. It will create actually wonders. I'm 100% sure about it. Okay. So have you ever sighted a space laboratory? Obviously, you might have. So if there are people who are still unaware of, you can actually spot the station. So you will be knowing that we are having a space laboratory, the International Space Station, which is always in the orbit, and it is orbiting at a velocity of say 7.66 kilometers per second, and you will be seeing around 15 to 16 day and night cycles when you are in the ISS space station. Okay, so what you have to do is, from the convenience, from the comfort of your home, you can actually sight those laboratory. It is flying in the sky. Okay, so you go to this particular page, spotthestation.nasa.gov, and you will be having an option to enter your city or town. You give a code, for example, for your Space Club members, and you find whether there is a sighting opportunity. 1 week opportunity will be shown to you, and depending upon the latitude and depending upon the duration, you can actually see that. Okay, because I used to see these things and get enthused myself sometimes when we feel low. These are the things that actually motivate us. Okay, so this is how the orbiting lab look like, and this is where most of the space life science research is happening. Okay, and you can go into the more details. This is again available with the NASA's website. They are maintaining ESA's website, because it's a collaboration thing happening, right? You can see the NASA is there, Roscosmos, the Russian segment is there, then JAXA, the Japanese counterpart, then Canadian Space, then ESA, everybody. Okay, it's a collaborative effort, hand in hand, but at the same time they maintain the identity when conducting their own experiments. So this is one place where we are really. So this lab is not a new one. It is more than 22 years old. Okay, so the point is, we are entering into a domain which is dominated by the research that is happening in this particular field. Again and again, I'm repeating, not to tell that we are far behind. No worries at all. Let us start from the behind, but make sure that we sprint enough to reach. Okay. And emerge as a forerunner in the coming days, and with all your whatever enthusiasm and the knowledge, whatever you are gaining over these years, definitely our country will be. It's a 100% optimistic thought from my side. Our country will be able to demonstrate huge strides in space biology in the coming days. Okay, so to tell you some of the examples of research, you must be knowing this woman space scientist. She's Christina Coach. She's an engineer, flight engineer. So she set the record for the single longest space mission by a woman to date. Okay, so she's conducting now. Working in the biofabrication. So during that expedition 60, she was working in that biofabrication facility. And again, one more biofabrication facility. This is actually a 3D printer. It's a biological printer. Why I am showing it is because, you see, they are trying to produce usable human organs in microgravity. So when you go for an extravehicular walk or something and coming back and you find that you're losing an organ, you simply go and give a command, the printer will be printing it out for you. Okay, so such possibilities are there. You don't leave any possibility unturned. Okay, you try. Okay, and over a period of time, definitely we will find a solution to any of the problems. So there is a saying, no problem can withstand the assault of sustained thinking. Okay, so that is very much applicable when we are learning something new and we are trying to do something new. Okay, and this is again another experiment where the bond densitometer validation is happening. Okay, so the bond loss is one among the severe problems which the astronauts face in space. And another experiment you can see here, they are actually trying to have the plant habitat. Okay, so this particular botanist, this particular astronaut is now cleaning the hardware. Okay, so again, one more point I wanted to tell, whenever you are in the space science research or space biology research, from very complicated hardware design to the running of the experiment, you are even expected to clean, because no, when you take animal samples and all, no, as humans and all, no, they all have the metabolism, every waste, everything is there, right? So we should be willing to, okay, to perform a lot number of jobs, non-technical jobs, whatever we call. Okay, so non-technical jobs also come as part of this particular missions most of the day. And when I'm talking to you and when you are listening to me on today, we see that ISS is currently on its expedition 66. Okay, there are some crew shifting happening. If you are following the missions by SpaceX and all, no, we already know that and the Russian stations and all, we already know that one, including a film actress, has now entered into the ISS. They are going to have a film shoot there. So that is another part of it. It's part of Expedition 66. It is going, the full-fledged thing is going to happen somewhere in the third week of October, maybe under 10 days to go. And it will it's expected to close by March 2022. So the point that I wanted to bring to you here is that from Expedition 65, I just chose a few of the life science as well as the so-called bioastronautics experiments. Okay, so the bioastronautics is actually the emerging domain. It is actually an aerospace engineering specialty where big number of people in the sense that expertise level, diverse expertise people will be joining to study and support humans or study and support life in space. That is what is bioastronautics, one important domain which is still it is yet to develop in India, but we are slowly starting it. Okay, so you see a list of experiments here. No, this marigold plant, they are actually cultivating it or growing it in order to find out the psychological benefits. Okay, these things we never used to think about, right? Psychological, because whenever missions are happening, you know, people are all under stress. But you imagine these people working in space stations when they are under stress, then what is the point in, how can they perform to their maximum? So the psychology, this is one important aspect of human space missions, dealing with the psychological attributes of life. Okay, so isolation, loneliness, this and that, no, they create a totally different you in you. So how can you tackle how can you fight with you and come out with the productive scientist or the technician, whatever you call as far as the astronaut is concerned. So even those levels of experiments are being conducted there. And you see that they are actually trying to find that one experiment, ring shear drop experiment, no? It is actually creating one shear wherein the protein aggregation patterns they want to study. Okay, and as a result there can be some clues related to combating the Alzheimer's disease and all. So I'm just mentioning a few of them to tell you about diverse amount of or diverse type of research with respect to space biology. And having food physiology, it is being studied because the immune function, the gut microbiome, then the nutritional status, everything will be at stake when we are relying 100% on so-called processed food for quite a long time, right? So currently they are all trying to build up veggie stations and all, so that our astronauts can use some fresh vegetables. And the Japanese people, know, they are so much fond of fish. So one of the areas where they are really exploring is with respect to the conduct of aquatic experiments. Okay, I will show you the complications of the hardware for an aquatic experiment when it is to be conducted on space. On Earth, no, you simply put one tank, you fill it with water, you put some food in between and all, no, they will be happily living, right? But if you want to conduct the same experiment or similar experiment with aquatic organisms in space, you are in some sort of a trouble. But people have actually found solutions for such troubles. Okay, so let's move on. And why should we talk about these things at length? Essentially, this is very much familiar thing to all of you, but I am just reiterating it because the big announcement happened some 3 years back, 2018, August, our Independence Day, that when we are country celebrating the 75th year of independence, we are we were trying to launch the human in space mission, right? So we all know by name Gaganyaan. So this is going to be the first man or human in space mission for India. And you see the pride, it is happening from Indian soil for the first time. Okay, so it is happening means we are all happy. Then how can we realize that particular thing? Because we have to take 3 crew members to an altitude of an average of 400 kilometers in Leo. Then we have to make them spend their 5 to 7 days in space, and then we have to bring them back, land safely on Earth. So these are the so-called the chain of events that we have to accomplish. So it is what is required is a huge responsibility, and as usual, ISRO has taken up that challenge, and ISRO is actually trying hard to make this mission a successful one. So all the centers of ISRO is actually supporting the Human Space Flight Center at Bangalore, who is trying to orchestrate the events with end-to-end mission planning, then development of engineering systems, human-rated engineering systems for crew survival in space, and including the process of crew selection and training. Now you know that the crew has been selected, the training in Russia has been completed, and the next processes are in process. Okay, so the why we are or what is our responsibility now? ISRO is able to handle many things, no doubt about it. But when it comes to the sustenance of human space flight missions, okay, one component of it is actually the science, the conduct of science in the orbiting laboratories, and bring back the benefit of science to the humanity. So throughout the history of ISRO, if you find many technologies have been translated. So whatever research was done for space, it was brought back to Earth to benefit the humanity. That was the vision with which the organization was set even, right? So we are meeting those vision, but again, to sustain the program, human spaceflight program, the 100% support from the academia, the research institutes across the country is required. Okay, so that is why we wanted to talk to you. Your role in space programs is going to be more than ever before. Okay, so whenever we are given an exciting opportunity, a big amount of responsibility is also coming up, right? So as school students, as graduate, students in undergraduate level and above, our aim should be to find or to have a firm footing on the science basics. Okay, so with that only we can proceed further and contribute to the upcoming missions of the country. Okay, so these are the details about Gaganyaan. It is found in open forum. You can find these details, and you may be knowing that preceding the original flight with the astronauts or the Gaganauts, whatever nomenclature is given, there will be 2 development flights, and these development flights will be assessing the performance of the real flight. So basically we want to simulate, or we want to give all the conditions except for the presence of the humans in the experimental flights. Okay, so why these experimental flights are encouraging or interesting to us? The reason is that these are actually offering, these experimental flights are actually offering a host of opportunities to conduct the several experiments, among which I have chosen the wonderful opportunity to conduct space life science experiments along with technology demonstration experiments. Okay, so when we are planning for any space life science experiment, definitely we need to understand the challenges when we take life into space, right? So the extreme environments of space flights, the low gravity levels, the radiations, the deprivation from the whatever free atmosphere, the food, water. So you cannot go there and tell I will only eat what my mom is cooking. Okay, you have to eat processed food, no other way as of now. Okay, and water bottle, consumables you have to take, including oxygen cylinders. So this all things, no, they're all real challenges, and the radiation levels are much higher here. No, we are actually very much protected in the magnetosphere of our Mother Earth, we call, right? She covers you with so many blankets. One is this magnetosphere blanket, the second is the ozone layer blanket. So many blankets are there, and we are very, very safe in the lap of our mother, right? But in the when we are so ambitious and we are trying to take life into space, obviously the challenges are there. But no worries, when there are challenges, we will be trying to circumvent them. We will be trying to tackle them, okay, with the growing what to say, knowledge as well as the expertise in the So I think somebody has switched on the mic, and please turn it off. So imagine that space is welcoming you. Okay, the moment the space that guy is welcoming you, know, he will be also giving you one warning board. You can see the signboard here, right? Warning, health and safety. Your safety is your concern. Okay, space will not take any responsibility for our safety. So we have to enter at our own risk. Okay, so what are the medical risks? I'm talking in the context of human space flights. Okay, so the medical risks in space flight, they have been documented, very many have been documented, but even still there are huge research gaps with respect to the fundamental understanding of the many of the processes. For example, in the case of as a consequence of microgravity conditions, one among the sequence or the consequence is actually the formation of kidney stone in astronauts. More than 30 incidents have been reported post-flight, the chances or the occurrences of kidney stone in astronauts. Okay, so currently in the first unmanned flight or first developmental flight, I should put it in that way, that is the right terminology, first developmental flight, we are actually addressing this problem, kidney stone problem. I will come to that in a few slides later. And these are the different health issues. The osteoporosis, okay, there will be calcium draining happening, and your bones will be becoming very fragile. Okay, have you seen when people are launched back? No, you see they are being carried into their stations, their medical station by crew members, outside crew members, right? The reason is that no, we cannot afford to have too much force to be loaded, because osteoporosis is one among the mechanism which happens when you are there in space for quite a long time. And I'm not listing every one here. You see, due to isolation and sensory deprivation, you can have sleep disorders. Okay, I told you now 16 times or 15 times a day you are seeing the light and dark thing. Okay, sunrise, sunset is seen. So whenever there is more of light, no, this melatonin production will not happen, and you will not be, the brain will not get the command when to go to sleep and when not to go. So there are several problems when it comes to space flight environments, and the artificial environment what is built for our stay in the space. Most of the time there can be hypoxia conditions, hyperoxia conditions, intoxications can happen, infections, microbial infections, so many, and space radiation, so many. I am not listing every one of them. And unpredictable accidents, very important. Okay, even to the extent of losing life can happen. Okay, but the good point is that we are pretty sure of the risks. So if we are sure about the risk, we can actually try making countermeasures, right? Exactly, that is what space life science is doing. Okay, so by doing the research in space life science, what we are trying to find out, or what we are trying to emphasize, is to conduct research and development and develop technologies to allow humans to travel safely and productively. It's very important. If somebody like a space, tourism, they can go and come back, no issues. But if you are there to conduct very serious experiments, you cannot simply go and come back, right? You have to spend your time productively in space. So in order to support that, in order to gain that knowledge database to find out the risks at the molecular level, what we are trying is to understand the space biology as a particular very important domain. Okay, so this actually the vision for India, from small biological systems. Currently we have started, then to human health, then to human explorations, and even our space station maintenance or space station living in space station, India's own space station by 2030 or so. Okay, so these are the areas where we can start working on. And what is more important is that the specialized ground and flight research facilities have to be established along the length and the breadth of the country. Okay, then only people can, because you are having a plan to do something. Because in the earlier session, or in the previous question answer session, you were asking our director Somnath sir how can you for his advice how to proceed. So one more important thing is to identify what all things are currently available for conducting research. Okay, so establishing this specialized ground and flight research facilities to study this altered gravity environments and the space environments, that is one thing very, very important that the country should be looking. So be it any space life science experiment, you just I'm just wanting to underpin this particular statement. The critical component is actually the customized hardware for the experiments. Okay, so when you broadly divide the space life science experiment into two, you can have automated experiments where your hardware 100% will be supporting the whole experiment. And needless to say, that design of the hardware is highly dependent upon the species that you are going to send. Because if you want to send a fish to space, the condition is totally different from what you want to have when you are sending microbes to space, right? So 1-to-1, that is why I have put the term customized hardware. So who will give you the inputs for the customized hardware? Our biologist will give you the customized hardware requirements, and the engineer, the hardware engineer, has to take it in full essence, considering that life is there. Then only he or she can actually go and make the hardware. The second one is actually the human in loop. Whatever experiments we are seeing in the ISS and all, no, they come under the human in loop experiments. And there can be even humanoid in loop experiments. That is also a possibility. We can think about such experiments even. Okay, and when it comes to human component being added into the otherwise complex space programs or space missions, the space missions become all the more complex, right? So currently what we are looking into is something called human engineering. Okay, so if you are familiar with the Institute of Aerospace Medicine in Bengaluru, it is actually Indian Air Force Institute. They are actually working on human engineering. So currently, there are a lot of opportunities for medical professionals to enter into the or to contribute to the space sector by the emergence of this particular human component into our space programs. Okay, so with respect to these body sensations and all, no, for example, different directions of accelerations. Okay, so if it is accelerated in this particular direction, the body will be feeling a pressure in the opposite direction. So your chest, you will be feeling a tremendous amount of force over your chest. So likewise, no, every axis when the flight is getting accelerated. So to understand what are the processes, because our body is highly balanced on 1G condition, right? So when we are exposing it into hyper G around 4 or 6 or more, even more, with respect to the launch vehicle capability and specifications, there are several challenges a body can actually face. Okay, so the common conditions, these things already because people may not feel like eating anything. Okay, when you are launched at this tremendous velocities and all, no, you will not feel like you feel so many bad things. Motion sickness will be there, then fatigue, insomnia, dehydration, some problems associated with your skin and all, no, and even back pain. Okay, so because you are constrained for quite a long time. So the physiological alterations or the physiological conditions can be short term as well as long term. Again, I'm not going into the details of this particular thing. The research article cited over here will give you more details. Okay, let us move slightly more faster. So here, no, lot of missions have been conducted, suborbital, low Earth orbit, and maybe some more. Okay, different durations of flight, short term and long term, and the challenges, environmental challenges the human body is subjected to. These are all listed in this particular research article. So these are all leading to, okay, so we can actually now summarize, these are going to be the very generic problems during the flight. Okay, and definitely it is highly dependent on the duration of the flight. Okay, and in some of the changes, the body is very intelligent enough to adapt to some of the changes. Okay, that is why after coming back to Earth after a space, inhabitation for quite a long time, some of the problems are normally they vanish out. Okay, that is the intelligence. That is a smart adaptation of the body, you can call. Okay, but there are certain things beyond repair also coming in. So medical data is available. Space medicine is that particular area where we talk more about the practice of all aspects of preventive medicine. We call it as preventive medicine because we know the problems, right? So how can we prevent the problems or the risk associated with the space flight? So the screening, it is one part of that. Healthcare delivery is one part of that. Then maintaining human performance. These all things are taken care. Okay, because the long-term health of space travelers, it is very, very, very important. So whenever you talk about the space medicine, it's a huge domain. Okay, so there are several aspects of that. Three of them I have put here because there are clinical aspects to that. You are having human factors engineering, and you are having assessment of human performance, okay, and through training, routine checkups, then special care or emergency, whatever. So many aspects are there for the space medicine. So the biospace medicine, we just try to provide the medico-engineering. You see the term medico-engineering, okay? So it is actually now, usually we used to talk medicine as totally different subjects, engineering as a totally, but when it comes to human in space missions, this is the beauty. You cannot be compartmentalized. You have to cross, or you have to walk across the boundaries, or else you just try to make the boundaries vanish. Let us work in the blurred boundaries, whatever we call. So this is very, very important when it comes to the human space missions. And fortunately, we have now the opportunity, the country has now the opportunity to work as a whole team to survive or sustain our programs. Okay, so the next, before winding up, I will just talk to you about a design of a spaceflight experiment. This is the experiment that I was talking to you about in the first developmental flight of Gaganyaan. We are actually in the process of developing a space biology payload, and you will be wondering what is this biology happening in. If you can see this one, these are called Drosophila melanogaster. That's the botanical name, that is the family, the species name. But at the same time, you'll be more familiar with this, fruit fly. In Malayalam, we call it as padaicha. Okay, so you will be finding they are rather disturbing things, right? If you keep your banana or if you keep any of your fruits maybe open for even 30 to 45 seconds, you will see these guys are there. But even though they are very nasty or naughty fellows for us on Earth, when it comes to genetic studies, they are one among the sought out organisms. Okay, so you see these people all here, no? They are sitting, they are happily smiling, or they are proud faces. You can see the reason is that these golden bugs were able to fetch them Nobel Prizes, 6 of them, including those in medicine and physiology. Okay, so this is the genetic organism that we are trying to use, and due to different reasons, we have chosen this particular experiment. And you see about these tiny flies, NASA Ames have documented, because they have 4 fruit fly labs in NASA, which is conducting continuous space biology experiments using these things. IST also has developed a fruit fly lab, a small one, but definitely will be growing in time. And as per ESA, you see many things that can happen to flies in space also happen to humans in the long term. This is something very inspiring, right? So with this inspiring thing, we chose Drosophila to understand the occurrence and the manifestation of kidney stone under microgravity conditions. Okay, so apart from that, we will be also trying to screen some of the small molecule inhibitors that our lab has developed in order to find whether we can have any control over the formation of the kidney stone. Okay, so this is going to fly in the Gaganyaan flight as an internal payload. So this is another classification: internal payload and external payload. Internal payload means the risk of exposure to radiation is not there. It is as good as the astronauts or Gaganauts sitting inside the cabin. Okay, so these are the space missions in which the Drosophila is already flown. So similar type of hardware we have already developed, and this is another set of hardware that NASA has flown. But this requires a human in loop. This is a human in loop experience. You can see because there are some changes or some human interventions required in between. Okay, so this happened in ISS also. Such research has happened in ISS also. So if you ask me, how did you go into this particular domain? Anybody who is working currently on Earth laboratories can migrate their work into space laboratories. Okay, so I have been trained as a synthetic organic chemist, so we were working in the molecular medicine area and all. So we synthesized many molecules. So in between, we found that this Drosophila melanogaster can be used in the drug screening process. So immediately, when the opportunity came, immediately we were able to cross-domain talks were done, and then we formulated this particular research thing. So the point that I wanted to emphasize here is that even though you can be an expert in a particular area, if you are trying to understand what is happening in the other areas of research, definitely it gives a tremendous amount of opportunity for you to design new experiments. Okay, so this microgravity experiment, science experiments, it is the one wonderful opportunity when the country is able to have its own human in space missions. Okay, so science experiments under microgravity, they have a very many unique features if you conduct microgravity research. For example, the convection is different, the different mass transfer processes are having different patterns. So many fundamental changes happen when we are taking these substances or samples into space. Okay, so ISRO actually will be announcing opportunity calls, that is announcement of opportunity AO calls. Periodic calls will be posted on ISRO website. Please keep a watch. Okay, so whenever you are choosing one experiment, for example, I told you now this is a zebra fish, and the Japanese people, they are very much eager to have fish. Maybe they want the fish to be as their source of protein in the forthcoming long duration missions. Okay, you see, these are the hardwares. All these are specialized hardwares for exclusively conducting the experiments using fish in space. That is what I mentioned. At home now, most of us keep a small bowl, and we put one or two fighters or whatever. No two fighters together. Fighters and all. We are having passion for this aquarium setting and all, right? But if you are really passionate setting up of an aquarium in space, it is really you are challenged as an engineer, as a scientist. You are challenged, okay? Because we need to meet several requirements. One is the functional requirement with respect to the species and all, because water is required. There is no other option. Then the other one is the structural requirement, because the hardware has to support, or hardware has to lead the structural, the vibrations of the launch as well as the re-entry, whatever. Then the space constraints can be there, mass constraints, so many constraints. Okay, so I just wanted to give us an example. So the challenges are very many, but pre-flight opportunities can be made use of. I will talk to you about 3 or 4 pre-flight opportunities or on-ground research facilities. Then definitely the hardware to conduct space experiments also becomes a bottleneck when we talk about space biology experiments. Okay, so in our lab there are a few activities ongoing in progress. That is the development of hardware for microgravity experiments, as well as some of the variable gravity platforms for Earth-based experiments like clinostat or a random positioning machine IIST has developed. Okay, so these are the pre-flight platforms. 4 of them I have listed. Out of that, 3 are frequently available. PS4 is not very frequently available, but still it is available. Okay, so these platforms you can make use of for technology demonstration or science demonstration experiments, then characterizing, refining, testing, calibration, optimizing of the experiments. You just design your experiment. Okay, it can be a test bed for a new concept, or maybe a continuation of existing microgravity research and all. And these are the microgravity simulators commonly used for Earth-based space analogous studies. This is a clinostat. This is the RPM. This is one that we developed in IAST. This can work both as a 2D clinostat as well as a 3D 3D RPM. This is a rotating wall vessel. Okay, it's another important aspect for conducting biological studies. This one, drop towers, we are having. This is actually the Germany-based drop tower. But in Indian Institute of Madras, we are having another drop tower. You can go to the website and see the capabilities. Parabolic flights can be used. This is the zero-G flight, which is used to conduct, which was used to conduct microgravity experiments, free-fall experiments by NASA. Other than that, large diameter centrifuges. This is again from ESA's website, but Indian Institute, Institute of Aerospace Medicine, IAM Bangalore, is having human centrifuge, and they are conducting some of the human engineering experiments in that particular facility. So we do have many of the facilities existing in the country. We can always explore that. So these are the capabilities, scientific ballooning, sounding rockets. I'm not giving, I'm not reading each one of them. So these are the facilities. This one is available with TAFR balloon facility in Hyderabad. You can go to the website and get the details. And very recently, IAST also has started ballooning, scientific ballooning, very small levels, but we are 100% confident that we will be growing significantly in the coming days. Other than that, sounding rockets, Somnath sir was mentioning a lot of research opportunities. We can add one more component, that space biology experiment in this particular platform. And other than that, PS4 orbital platform, and now you are being offered an opportunity to work with the PS4 orbital platform, provided you are having your experiments with you. So IST already flown one particular payload. It is called Ares, which was a very highly successful one. And other than that, these are the PS4 opportunities. These are the current capabilities which PS4 can offer. This may vary from time to time. Okay, so the important point that I wanted to tell you is that the designing, then conducting and optimizing ground-based and pre-flight experiments can be the good, or it is the best starting point to start space biology experiments. This is for you all to understand. So if you find that things are very complicated, and if you find some sort of demotivation, no need to get demotivated at all, because we are 100% sure that whatever accomplishments with the hard-earned or hard-tried success we are getting in space, it has a huge impact on Earth. Okay, but among them, the space life sciences have been the leader in giving most of the contributions back to Earth. Okay, most of them, actually more than 1,700 products are listed as spin-offs from space technology, several in medicine. So medicine means the common man is getting benefited, right? So never ever think that we are wasting money on space. No, never, because space makes you a meticulous person. So you will not afford to make an error. Okay, so you will try your best to make an error-free experiment or an error-free prototype or a whatever product. Okay, so in that way, you can refer to ISRO's website also to find and motivate yourself towards the space biology experiments. Okay. So whatever be your motive, or whatever be the research domain that you take in, perseverance becomes the key, and it is more important or most important when it comes to space biology, because this one I always want to show to our students. You see this guy, this is actually the Kennedy Space Center, but we will replace it with SDSC Sharp, our own launch pad. So with the know-how and the survival kit, the guy is starting. Then the design of the flight hardware, so many steps. This is a space biology person, okay? He's starting from here. You can assume me to be here or my group to be here. Okay, so several of the hills, big ones, okay, we have to, and this is something that is quite worrying me. Upon reaching here somewhere, quit teaching. That I think I don't want to quit teaching. We need to be teachers, then only we can learn from students. This is one of the most beautiful experiences in this life, learning from students. Okay, so this is a hard journey or a long journey. You can see up to 8 to 9 years it may take up to reaching an application level. But nonetheless, if you are able to demonstrate, and if you are able to transfer something to the society, of course, all these hurdles will be gone, and we will be only looking at beautiful scenery from the launch pad or beautiful scenery from our labs, right? So that is the passion or the motivation with which the researcher has to proceed. Okay, so I just wanted to tell you, because many of the school students are there, so most of you may be interested in space, and this is one question usually you will be asking, because after my school +1 +2, or during my school, if I'm choosing or if I'm having more of affinity towards one subject, will it alter my space career dreams? Never. Okay, because any field, if you are strong enough, if your fundamentals are strong enough, space is that particular arena where every knowledge is significant. Every knowledge can be made part of a mission or a program or a scientific experiment or whatever. So there is no worry. You proceed. It can be economics. It can be even communication. Okay, you proceed with whatever you like, and you will find definitely a way of then linking yourself with the ongoing space program. Okay, so the redesign your continuum of learning, that is what I wanted to tell you. And definitely there are many key ingredients when you are in the making of a space researcher, especially space biology researcher, because you need to have an exposure. International vision should be there. You should be very much proud about your nation, the national spirit. It should actually propel you every time there is a chance that you are going to get tired. The national spirit will make you stand up. Okay, you are doing something for the nation, you're doing something for the people of the country, means that spirit should be there. It will propel you, no doubt about it. And whatever field you choose, stay committed to that, be a benevolent person, and above all, you should have unabashed optimism. For that, Arthur Clarke, in his theory, whatever he was telling, if somebody is telling you cannot do that, you don't admit that. Okay, you try on your own way, so you will be able to achieve that. So with that, I think I have come to the end of the presentation now. My slide is now not moving. I think the final slide is our thank you slide only. So with this, I think it's time to thank you all, especially the UL Space Club members, the organizers. So here, few more photographs only I'm showing. Just, I think you are seeing this one. And before that, I had one slide where plants, animals, human beings, all sort of living objects are having a harmonious life inside the we can learn from experts, and we have lot to continues to have the indigenous is moving back and forth. Okay. Yeah. So I think sorry. So these are some of the, this is just a gallery only. Yeah. This is our former director, Dr. V.K. Dedwal, sir, because in the initial days of this space biology formulation, this is Dr. Sharmila Bhattacharya from NASA Ames Fly Lab. And this is my collaborator, current collaborator, Dr. Ravi Kumar. This humanoid and all, Okay, so we learned from many people. We hired this person, Anupam Agarwal, Dr. Anupam Agarwal from Indian Institute of Aerospace Medicine. All of them, they have a huge amount of knowledge to share with you. Keep your mind open and get ready to design your space biology experiment. Are you ready is my question. So obviously, a few of you will be ready to design your space biology experiment. As I announced earlier, you have 1 month time. So November 8th, I suppose I have given the deadline, November 8th, 2021. You please send your whatever plans to me at this particular email ID, sreeja@ist.ac.in. And with this, I want to express my sincerest gratitude to all the organizers of this particular event, and especially my institute, IIST, and all the ISRO centers and all the veterans of ISRO community, and definitely to my students and collaborators who have been supporting me, who have been keeping me happy most of the time, and challenging me with many of the problems as well. So finally, I would thank each one of you for your kind attention. And yeah, with that, I'm stopping here. Okay, Varun, I'm done.
Varun, may I?
Yes, sir. Yes, sir.
Varun?
Yes, sir. Yes, sir.
Yeah. Thank you very much, Dr. Sreejalekshmi. Actually, you have asked us, are we ready? Yes, our students are definitely ready. They will definitely take your challenge and respond to you back with their proposals. I am assuring you that. And once again, thank you very much for the most informative, motivating, inspirational, I don't have words, adjectives, and illuminating talk on astrobiology, probably the most advanced frontier of space sciences. And thanks for introducing our kids to the infinite possibilities of biomedical engineering. This particular stream only will take us for in the future overcoming the challenge to, especially with the NASA's challenge of the grand challenges. One among them is to have sustainable presence of human in space. So this is biomedical engineering is one area where it's going to bring rich dividends, and you are doing wonderful work for our country. And with all the blessings and your hard work, no, definitely we will succeed. So thank you once again. Now we have an interactive session with the students, and we have today amidst us one of our very brilliant student, despite having some differently abled and she has having severe medical limitations. Despite that, she is a great. This one scored 200 out of this full 100% out of the possible marks in this one, and she's very passionate about astrobiology. So she is there, and some other students are there. They are all looking forward to interact with you. So Varun, can you take over?
Yes, sir. Ma'am, we didn't get a lot of questions in the chat window. Okay. But we have one student, like Jairam sir said, she is one of the most brilliant students in UL Space Club, and she's really interested in astrobiology. The first time she participated in the UL Space Club program, she was talking about astrobiology. So Arya, over to you.
Hello, Arya. Welcome. Happy to meet you.
Thank you for your wonderful presentation. I would like.
I'm happy, Arya. I'm happy that you liked it. Very happy. Yeah.
I have a question.
Please go ahead. Yeah.
Organisms like tardigrades are survived from 5 mass extinction. So I think that they are more adaptable bodies. So can we make experiment on that?
Yeah.
Tardigrades.
Yeah, I got your question, Arya. It's a wonderful question, and you put the correct question in the context of astrobiology. Okay, so Arya want to know about tardigrades. So tardigrades are one among the extreme survivors or the survivors of extreme environments. Okay, currently they are also called moose piglets or water piglets. So many other names are also there.
Yes.
So yeah, as you mentioned, they do have very unique mechanisms to combat, be it radiation, be it heat, be it pH. Okay, you can boil even a tardigrade. You know that, no, Arya? Yeah, it's a very interesting story. So the point I always tell my astrobiology students about tardigrades, you know why? Because they actually show you put me in any harsh environment, I am going to survive. So Arya, you can also demonstrate the same thing, right? We will travel together. Okay, from now onwards, we are a team. Arya and I is a team. Okay, so we are team members. I'm shaking hands with you. Okay, so we will move together, and maybe even we will try to devise or design some experiments to fly in our nanosat or something, which is ongoing with our Arya's idea. This is a word from me. So several defense mechanisms are there, and
it's also hibernate.
They hibernate, so they can actually remain dormant. Or if they want to establish, or if they want to leave, they can leave.
Yes.
You imagine such a thing for human beings also very good, no? Sometimes we don't want to leave, but the very next time, no, we are back with that. Yeah.
Suppose happen. genetic engineering, the gene of tardigrades, and the gene of
Exactly.
can combine together.
That is a one possibility, Arya. But at the same time, no, there are certain restrictions for genetic engineering. Otherwise, no, people will try to make whatever extraordinary or superhuman type of thing, no, and they will come and attack us. That's not good, na. We should be safe also whenever we are doing research. Yeah, so like that, no, it is a possibility. It's a huge possibility of genetic engineering, but there is a dark side to that. That is not a good side to that also.
Yes.
Okay, so we will not. I mean, for that matter, for a research like thing, it is good. But when the research becomes uncontrolled, like in the case of coronavirus, that is the same thing happened. No, people were researching. We were happy, we were not knowing, but when it became something uncontrolled, okay. So like that, the same thing, genetic engineering can be done, but advisable not to do that.
Yes.
Yeah.
And one thing is, Arya done a very great presentation, a wonderful presentation last time, and the Dean of IAST, Vaidyan Krishnamurthy sir, was stunned by the presentation.
Yeah,
we
I
appreciated Arya.
Correct. In this context, I also want to thank our YVN sir, because he only suggested me to be a speaker in this particular forum. And I should tell you, I'm really excited after coming here with the passion of the very young generation plus very senior. Okay, this is a blessing for me actually. I'm seeing Nagesh Rao sir here, Banaram sir here. So many people are here. So it's a blessing to be in front of you. And Kutti sir, no? Like a doyen in the field. He is actually there to help you, support you. Means this is great. Arya and team, no, you are having a real great opportunity.
Actually, we are grateful to Arya for getting Dr. Sreejalekshmi here.
Okay.
Because ever since I met her when she was in 8th standard, in a space camp, 2-day long space camp, one night they stayed. That camp, she inquired about space astrobiology.
Yes.
We don't have many students so much keen in that. We have very few, and she is the leader of that group. And when it came to this World Space Week celebration, we tied up with IAST and thought of requesting them for this topic. Because Arya and few others are interested. Another thing that has happened is Arya, in her 12th standard +2 examination, scored 1,200 out of 1,200 marks. And very many people felicitated her, including the High Court. The High Court judge from Ernakulam came to Calicut to personally congratulate her. Very many people, very many organizations did it here.
Definitely. I would, in the next opportunity, sir, Kutti sir, I promise I will come and meet Arya in person. Okay. In the very next opportunity that I am getting. So we will have a great teamwork, Arya. Okay. Wait for the next few decades to come.
Thank you, ma'am. Thank you very much.
Okay.
Ma'am, before going to the next session, there are not a lot of questions, but I want to ask one question on behalf of all my friends in UL Space Club.
Yeah. One more thing, Varun, if you can compile these questions and send it to me. I will try to address few of them because we need not miss it out, right? Because
yes, ma'am. Sure, ma'am. I'll send it to you.
Whatever you want to know. Yeah.
Okay, ma'am. So, like Arya, there are a lot of students who have no idea about how to study about astrobiology.
Exactly.
They are really interested in astrobiology and there are many points connected to astrobiology, but they have no idea like astrophysics or space technology. Astrobiology is not that much public.
Exactly.
That much popularized.
Yeah,
so,
in India, you have to put it in this way, Varun. In India, it is not popular, but elsewhere it is highly popular. Okay. So we are trying to popularize it now. Yeah, please.
Yes, ma'am. So what's your message for the students, and how do you want to guide that students to get into astrobiology?
Yeah, so in fact, in IAST, currently I am running one course on astrobiology. it is being offered to the BTech 7th semester. That means final year students. We have an option called choice-based credit system. It's a system that is followed in foreign universities. Okay, so an aerospace engineer or an ECE engineer or even engineering physics student, they can take any of the elective of their choice, one of them. It can be even music, arts, or whatever. Okay, so in that we are offering astrobiology also. So we are having one student group already working, and some payloads with respect to this student nanosat mission or CubeSat mission and all. No, it is already there. It is ongoing. Okay, so that is why I wanted. Let us see whether some of your proposals. Okay, and in between there's a huge difference between astrobiology and space biology. That is also I just wanted to emphasize. Okay, because in astrobiology we are searching for life elsewhere. And we are trying to find out the origins of life. We are trying to find how it evolved into the current form. We are trying to find where it is going. Okay, but at the same time, in the talk that I was talking today, it is taking life from space, from Earth to space, and find out what are changes happening, then bring back safely to Earth. Okay, so these two are actually different. That is why the experiment, what I wanted you to propose is from space biology, where we do have platforms to conduct such experiments. Okay, but in the case of astrobiology, in IIST, we do have, this program is run by 3 departments, in fact. Okay, one is the Earth and Space Science department, where astronomy, there's a component of astronomy coming in, because we are searching for stars, we are searching for other galaxies where life can be there, Goldilocks zones and all. You people will be knowing all these things, right? So we are searching for life. In that astronomy thing, measuring certain parameters in other planets and all, no, to find whether habitable worlds are existing. And in the second domain, we are having planetary geosciences, where we are having geology professors dealing with this particular module. Okay, a third module actually deals with the astrochemistry part of it. What was the molecular basis when life originated? Okay, and the fourth part is actually whatever you were talking about, the survival in extreme environments. And usually we wind up with the importance of learning these things in the context of human space programs. So already the program is running, Varun, for the information, all the club members. You just write to me telling your interest. Okay, we can even start an astrobiology chapter or an astrobiology segment in your space club. I'm willing to help you. Okay, you just tell me what you want from us. Okay. This is what we want from you. You demand, then we supply. Otherwise, no, we will simply leave and go. What is that? No maza, no. There is no entertainment in that. If you tell, ma'am, we want your support, means, okay, we are there. Okay, I'm not simply telling it. I just mean it when I say it. Okay, just write to me what exactly you want to. Then I will be telling to do a lot of homework. That is something I cannot, that I will make sure that you will work. Then you should be perseverant. I mean, that is what perseverance is the key. I told you, na? That is the reason. Okay, because passion is something like a mushroom. It is coming up and going, fading, means that is not good. We have to be persistent with our passion, isn't it?
Yes, ma'am.
Yeah. So for that, no, we will train younger schools, because Varun was telling, no, you are disappointed because I gave the opportunity to school students. I can open it, no problem. I don't want to restrict anybody. Okay, anybody from your space club or associated mission, you just put it up, no problem. Okay, I'm removing that barrier for you.
Okay, thank you, ma'am. And one final request, with the permission of Jairam sir, I request you to please give us something to publish in our magazine, something about astrobiology.
Yeah,
we are running an e-magazine, which you have already seen here.
Yeah. So
I kindly request you to.
Planned, Varun? When is the next issue planned?
Ma'am, December, ma'am.
December. Okay.
It is a quarterly magazine, so we look forward to some of your creative input.
Yeah,
actually, madam, now that question and answer session almost coming to a conclusion. In fact, I had a question which you intrally I answered. Actually, the differentiation between the two terms we come across. One is about astrobiology, which is essentially looking at the existing life and going after it. And the other time that
basically how we came to existence.
Yes, exactly.
And are we Martians is one question, big question in astrobiology.
And the other term says that I also came across when I was trying some reading. No, it talks about space synthetic biology.
Exactly.
So these terms should be differentiated. Actually, you did that.
In
so
fact,
students also should take note of that.
I understand. Space synthetic biology is, in fact, we can call it as an advanced version of biotechnology, what we know. Okay, so you add a component of aerospace engineering into biotechnology. The conclusion what you are getting is actually space synthetic biology. Okay, so with that, you are actually like what our Arya was telling. For example, sir, tardigrades. If you can isolate the proteins, if you can find out what makes them that, resistant for a wide range of conditions, that element which can impart that high toughness or resistance or whatever, you can bring it into industry. We can convert it into some products type of thing. So that level of research is happening in space synthetic biology, including the habitat building. Okay, yes. So many cybernetics is another branch in space synthetic biology, because cyber security and so many. It's some 7-8 grand challenges. It is existing in current space synthetic biology. I didn't put that slide because no, I thought all our school students, so I should not bombard them with so many things that they get scared. I just want them to get motivated. That is why I put it in an introduction too. Okay, yeah. So that's a wonderful area, sir. Jairam sir, we can.
Probably I would request you to write an article on these grand challenges.
Sure, sir. Sure, that can be done.
Thank you very much. Thank you very much.
Thank you so much. Thank you so much.
Now, Varun, next item is official Thanksgiving, I believe. Kuti sir, can we go ahead?
Yeah. It's actually time has flown like anything. You know how 2 hours and I think it is 45 minutes or so has gone like anything. See, absolutely, this thing is such a fantastic, beautiful session, which you think should never end. That kind of thing. And I have here with me my lifelong friends, Dr. Nageshwar Rao, Padmanabhan, I don't know, CBS, Dutt, Joshi, PJ Bhatt, Hegde, I don't know, so many of them are here, We have not given them an opportunity. They are such veterans and just listening us. I feel so sad because they have a lot of things to convey. But the thing is like that, any program, it has to have its own structure and method. So I'm very sorry I express my regret for not able to showcase you or at least give you an opportunity to say a few words to students. We'll do it in a proper occasion. So astrobiology has made a lot of impact here, and I'm very, very happy that we have not been able to take Arya Raj to many places. When our students went to VSSC, LPSC, ISAC, URSC and all those things, she couldn't get an opportunity, but at least she got an opportunity to directly speak to you and also to strike a kind of a collaborative thing with a student and a teacher. Thank you very much, and please proceed, Manasa. Please proceed.
Manasa, are you there?
Yes, I'm here. Thank you, Kutisa. As a part of World Space Week celebration, we have been conducting a lot of programs, prominently skywatching session, webinar at schools program, etc. And your Space Club has a lot of programs coming ahead, like model rocketry workshop, idea pitching competition, and the real-time space-related projects coordinated by our student fellows, Varun, Abhinand, Ashik, Bharat, Sriram, Adil, and the team under the guidance of our mentors, Kutisa, Jairam sir, and other mentors. And we expect all kind of support from VSSC and IST, ma'am. And without any further delay, I am coming to my duty. My duty is to present vote of thanks. First of all, I thank Somnath sir, Director of VSSC and IST, for spending your precious time with us, sir. And next, I thank Dr. G Sreejalekshmi, ma'am. And it was such a wonderful presentation, ma'am. We had a lot of things to study. And I thank Kutisa, Jairam sir, and other mentors, and all other ISRO veterans. And I thank Ashwati, Varun, Bharat, Abhinand, Sriram, and other UL Space Club coordinators. And I thank all the participants came here to attend the session. Thank you.